You take these cells, individual kind of energy sources. One of them can, let's say, go into a flashlight. Four of them can go into a laptop. And now 9,000 of these go into a Tesla.
What is the problem with fast charging? Is it just degrading battery life, or are there other challenges with fast charging?
So I actually have a huge safety concern within my battery if I keep fast charging, and I basically damage my cell, which then leads to thermal propagation, fires, etc.
Why is there still lead acid in the world?
In the past, obviously, we've heard of lead being used. We've heard of 100 other materials being used. In the future, we might have water batteries.
The reason why I wanted to get you on the show is to understand battery from the nuts and bolts upwards. Just take me through what exactly is a battery and how have you seen that technology evolve?
Sure, Akshay. So the idea is that batteries essentially are kind of, in a way, magical energy storage devices. So you have electrons basically inside them. So boiling down to the most basic electrochemistry here, right, which is really what batteries are. You have small cells which have certain materials in them. Those materials over time react with each other and basically produce a certain amount of power. So what's unique to the newer cells that exist is that they use lithium as their main chemical. In the past, obviously, we've heard of lead being used. We've heard of 100 other materials being used. In the future, we might have water batteries. But the idea is that today, from a global perspective, lithium is the best placed material to produce a battery. Now, what happens inside a battery? So you'll most likely see like round cells. You put them in your remote. Now you put them in vehicles. The remote cells are obviously smaller. They used to be a nickel metal hydride kind of material, which obviously is a little different. And now you have bigger cells, which are lithium based, which are going to cars, bikes, and even energy storage now. They're pretty much the same thing. So if you open this up, what you'll see is an entire roll basically being wrapped around each other. So what there are is, if you completely dissect this, there's three layers here. One's what people call the cathode, then the separator, and then the anode. Now, all three of these basically are very critical. The cathode and the anode are basically positive and negative and basically interacting with each other. Lithium is basically transmitting from one electrode to another and then basically going back and forth. So when you discharge, it moves from one side to the other, and when you charge, it moves from one side to the other. What binds all of this together is a material called the electrolyte. So that basically is kind of becoming the medium for this transfer. So from cathode to anode, you separate this with a separator, and then you have this electrolyte which allows that transfer to easily happen from cathode to anode and back and forth. This, in the most basic words, is basically a battery. And a lot of people in school have seen the potato test or like a water where you do like a plus and minus and you see like a circuit form. So now if I connect like a motor, or if I connect a switch, or if I connect a light of some sort to this battery, I can actually see electricity flow. And the actual, one might ask, like, why is this happening? Like, why is lithium basically just reacting this way? So there are concepts of electrochemical potential and basically like how voltage is allowing this to happen. But at the end of the day, it's magic. It genuinely is pure magic as to why this is happening and why lithium, why electrodes basically exist, why electrons move. All of this we won't get into. But if I take a history of batteries and today see where we are, last 15 to 20 years have been absolutely kind of incredible to see like what kind of battery progress we made, right? As a civilization, to be honest, because 20 years back, nobody would have imagined the kind of power, the kind of energy, the kind of applications we're doing with batteries. So now what's happened is you take these cells, which are basically individual kind of energy sources. One of them can, let's say, go into a flashlight. Two of them, if I basically combine and then basically add together, can maybe go into like a small little gaming controller. Four of them can go into a laptop. So I'm basically combining cells together to get more power, more energy. And now 9,000 of these go into a Tesla. So that's the scale of these. Like you can basically grow from four, which are going to a laptop, and literally the exact same cell 20 years back, Tesla basically took and started placing into cars. So they started with basically using laptop batteries. They connected thousands of these in what we call series, which is basically increasing voltage to a high enough point to where you can then operate them. And then you also connect them in parallel, which basically then allows you to produce a certain amount of current. So voltage and current then when combined produces power, and then over time that produces energy. This is really in fundamental like concept what a battery is. So like if I had to basically give you like more technical words to these, so the cell is the most kind of basic constituent. So one of these that you see a cylinder is a cell. Thousand of these then become basically a battery system.
Why are the mobile phone batteries flat? They are not cylindrical.
Right. That is a very good point. So if you see certain applications, they'll basically have flat batteries instead of being rolled up. Now, what's actually happening is, so you still have the same thing. So instead of rolling, you essentially just keep creating sandwiches and basically kind of combine them one behind the other. So you have cathode, anode, separator. You kind of keep stacking these one over the other. They're obviously mainly for packaging reasons, because a cylinder obviously would be too large for a phone. And from a very safety perspective, taking that and just making it very, very large is basically then what you call a prismatic cell. So that's basically a pretty large concept in automotive too, where you have pouch cells and prismatic cells. So they're very large phone cells basically. They have their own advantages. They're actually much lighter. They have custom packaging. But if you've seen an old phone and if you've seen the cell, it's just giant. It's basically like just, yeah, it's very pressurized towards the end of life. So it basically becomes like a giant puffed up balloon, like very highly pressurized. So
Yeah,
that's
yes, that's
a
puff
very,
up. Yeah.
exactly, it's a very giant safety risk, I'd say. And that's why you usually use phones for 2 3 years and then pretty much discard that, because that battery is pretty much gone to waste. And cell phones use the kind of soft pouch cell that they're basically using. Most cars are going away from, but some vehicles still continue to use them. But yeah, that's a good point. That's a different form factor. So pouch or prismatic essentially instead of cylindrical.
Why do you need a separator between the anode and cathode? You're saying that lithium molecules move between the anode layer and the cathode layer, and that is how either the current is being absorbed and stored, the energy is being absorbed and stored, or the energy is being released, depending on which side the lithium molecule is moving towards. Why is there a need for a separator in between?
So if I take the plus and the minus here, essentially, if I basically allow them to directly contact each other, that basically creates a short circuit. Essentially, if you basically take a rod and essentially just shove it into your like socket, you are essentially becoming a conductor. You are so now seeing that short circuit happen. So essentially, the same thing is happening in cells. I want to basically create a separator, and that can be multiple materials. Basically, it's completely providing electrical basically isolation between my anode and cathode.
So, isn't lithium supposed to be a metal? Because I remember rare earth metals as the terminology used for all of these lithium, nickel. So how is that metal operating in that liquid and moving from one to the other, from cathode to
Yeah,
anode?
that's a good question. So today, what actually, when if I take the entire production of cells and how cells are actually made, what's actually happening is that right in the first or second step, I have multiple powders that are being basically created. So I have a lithium powder, I might have nickel powders, I might have cobalt, and these are all being mixed to create what they call a slurry. Essentially, this is basically then applied as a uniform paste over a certain material. So that might be an aluminum conductor or a nickel or a silicon anode or whatever that might be. It's basically applied over it. This then basically transmits all the way back and forth from the electrolyte. So you're right, metallic, in basically when you're extracting ores, you're essentially getting this large metal. They're basically extracting it in powder form, then creating slurry, then depositing it on anode and cathode, and then forming a cell essentially.
Okay, okay, interesting. And the rare earth metals are largely in China, I guess. So China would be providing cells to most of the world, or like who manufactures cells?
So rare earth, I guess metals are basically spread out all over the world, right? So you have some in South America, you have a big chunk in Australia, like parts of Asia for that matter. The one big thing China has done very well, and even though they have some of them themselves in terms of like ores, and they've essentially become the mining partner for a lot of these countries. So if you see a lot of these companies, Venezuela, Chile, some parts of Africa, they aren't the most developed countries in the world. What China has done is basically provide economic assistance to these countries to develop significantly over the last 10, 15 years and become their mining and processing partner. So it's interesting to see that China, at least 20 years back, had this game plan knowing that this would become like a very large part of the world's, let's say, geopolitical kind of behavior too. So they've essentially, I'd say, at least 90% of all processing, refining, mining, basically for these metals happens through China, if not directly in China. So even today, as a cell company, if you were basically trying to, let's say, set up a cell company in India, a lot of those materials, once processed or refined, would in a way come through China. I think a lot of companies are setting up raw material processing also, but today they are, yeah, leaps and bounds ahead in that particular category at least. And which is why they've been vertically integrated to now set up production also, and then do cell assembly, then battery pack assembly, vehicles, all the way from literally mining lithium to basically shipping the vehicle to its destination essentially.
Okay. Take me through that journey from mining to battery in Tesla.
Yeah,
What are the
absolutely.
steps in that? Yeah.
So today, I'd essentially start basically the first step is to basically find those materials. So you have reserves across the world. You basically mine these key materials. All of those would essentially go to some kind of processing and refining center because the absolute kind of refinement you require is basically 99.99, etc. All of these are then basically processed into a cell factory where then they're forming the slurry. The anode and cathode might potentially be made in the same facility, but you might just get rolls from, let's say, multiple companies like aluminum foils, like copper foils. You'll get like a stainless steel can basically pressed from somewhere else. And now all of these components will start basically coming in together to basically produce a cell. So the actual process of where the winding happens, where the tabs are attached, where the cylinder goes through, all of these happen in one cell factory. The output of these is essentially that full proper container of cells, and like each box might have like 130, 150 of these. Those boxes now get shipped to a battery pack company, which might also be the vehicle company in case of Tesla, or might be different for some other people. At the battery pack company now, it's basically that company's job to essentially place all these cells together, electrically connect them, do a lot of safety checks, attach all the electronics, a lot of sealing, a lot of mechanical bonding, and basically creating one final system that can then basically go into an automobile or into an energy storage system. So in this case, if it's Tesla, Tesla has a battery pack line. They basically produce their battery pack, and now it's basically shipping out of their battery pack line to go into their vehicle assembly line, where it then gets attached to their chassis. All the electrical connections to the motor controllers get made, and essentially shipping out a vehicle. So I'd say there's at least six people involved from mining, processing, refining, cell assembly, pack assembly, and then the final application assembly.
So these household names in India, like say Exide, Amara Raja, what are these? Are these cell manufacturing, battery manufacturing? What do they do?
So interestingly, if you see lead acid actually cell and pack are exactly the same thing. So when I see like a lead kind of plastic container, which is basically one
Lead acid is
battery.
like first generation technology or something like that, and this lithium ion is second generation.
Yes, I'd say yeah, lead acid has been around forever. It's a much like safer and a much lower energy and power way to do things. Lithium is a much more what I'd call like dangerous metal also for that matter. But with that danger also comes excess power. We've also as a like society kind of been getting more used to how to use lithium over the last 20, 30 years. But yeah, that is really the big issue. Like lead is obviously dangerous in its own different ways. But from a usability perspective, there's no flammability issues, which then doesn't affect the user. So yeah, it's I'd say first gen in a way. Nickel metal hydride and some others were second, and now lithium is basically pretty much everywhere. Yeah.
Okay, so yeah, we were talking of what an Exide or Amara Raja,
Yeah,
what
so
these
lead
companies
acid
are.
essentially you'd basically start. The interesting thing about lead is all the way from producing the raw material of taking lead and then making into a pack, pretty much all of it happens in one line. So you essentially just buy lead ingots, which basically is literally the raw material. You're buying it from somewhere. Lead is obviously a lot more easily available also. You essentially like start melting it, start basically kind of distilling it in certain ways and produce one pack. So today, Amara Raja is basically sourcing material, producing the cell and the pack all for lead acid. Now, transitioning to lithium, what's happening is Amaraja and Excite both, in certain ways, have battery pack assembly today in a very minor scale. So they today buy cells just like anybody else from different parts of the world, bring those cells to India, assemble them into a pack, and then sell them for certain applications. But what they're also in parallel starting to do is basically set up cell assembly. So basically taking may potentially the raw materials from different places, most likely refined and processed, and then assembling them into a cell, which then you can put them into a pack. So they're taking stage 4 and 5 from this, and then basically continuing on. The first three stages, which is mining, processing, refining, are still happening somewhere else.
Okay, okay. Uh, Why is there still lead acid in the world? Why doesn't everyone use this third gen lithium ion battery?
Yeah, I'd say there's the biggest factor over everything is cost. The idea today is that lead acid still is sub $30 a kilowatt hour in a lot of systems. Lithium is just about starting to hit that price in China. Like you're at $35-40 a kilowatt hour on cell level, on system level, you're $70 a kilowatt hour. But also, one of the major reasons is the entire safety and usability of lead is just so much easier than lithium that it just allows that the applications that are already, let's say, lead focused, let's say, so residential home storage, backup, a lot of, let's say, telecom for that matter, it just works. But you can already see that the transition in two wheelers and vehicles has been so fast to lithium because the power, the energy, and that power and energy per kilogram and per rupee, let's say, is so much higher than lead that it makes perfect sense. I'd say most applications that lead is dominant in today will start to go lithium in the next 5 years. There is a definite push, even from the safety side, that obviously some people haven't solved for, but I see that getting better and better over time. And even lithium itself is improving to, let's say, its own next generation, which we can come to later, where the electrolytes improve, some of the anodes improve to basically give this like next generation of safety, essentially.
Okay. What do you mean by energy cost? Like energy per rupee, energy per
Yeah,
kg.
absolutely. So the most important metric for lithium that most people track is dollars per kilowatt hour. So it's essentially how much am I paying for 1 unit of electricity, or 1 unit of electricity basically move essentially, right? So when I
So
have one
you're saying like
kilowatt hour, yeah,
storage capacity of 1 kWh.
1 kilowatt hour, yeah, absolutely. Yeah.
Okay. Hmm.
So for every kilowatt hour, essentially, there's a certain price I pay. That price has been constantly changing over the last 5 years. 5 years back, it used to be close to 200 $250 a kilowatt hour on cell level. That's down to 30 $40 a kilowatt hour now, which is kind of insane. But yeah, I think China has had a huge role to play in terms of production output and in terms overproduction in a way, essentially.
Uh, you said it's $35 at cell level. What is the next level? You said at system level it's $70.
Yes,
What do you
I'm
mean
going
by
to
system
combine
level?
all these cells to make a battery pack. Let's say I might
Hmm.
put that battery pack into a car, or I might put that battery pack into a energy storage. A lot of these from China at the lowest level are around $60 $70 a kilowatt hour. India is hitting those costs for certain segments, like the low cost segments, but not all the segments essentially. Because some require better power, some require better safety. They might require just overall better systems, better cooling systems, better electronics. That bumps up the price to $100 $120 a kilowatt hour.
Why is there such a massive bump in price from cell to battery?
So you also use better cells. So like some of these cells are at $60 $70 a kilowatt hour. If I take like the really premium cells like from BYD, CATL, which are also using lithium, but they're essentially using different combinations and different chemistries combined with that lithium. So even within lithium, there's actually hundreds of variants of chemistries within that. So the two dominant ones are NMC and LFP, which is basically nickel manganese, cobalt, and then basically ferrous phosphate, lithium ferrous phosphate. These two are basically just branches of lithium chemistries. Now, even within these, there's a cost difference, and even within them there's a cost difference. So like they might have like five different variants of LFP, five different variants of NMC, and all of them will essentially have an impact on what the final cost will be. So I might start with like a very good premium cell at 100 $120 a kilowatt hour, and then build a system maybe at a $200 a kilowatt hour. But the advantage is that I will get better life. So I'll be able to give better warranty to my customers. I'll potentially be able to charge that pack much faster. I'll give more power to a car, so I'll get more horsepower. And essentially also just provide a much safer solution for a customer while doing all these things. So that's where the cost kind of kicks in, even within the same lithium chemistries, essentially.
Uh, So, what I want to know is this: suppose you're using cells which are costing $30. What is that additional $30 being spent on so that the battery is costing double? Like I thought, battery is just like a container where a bunch of cells are wired together. That doesn't seem like a very high overhead for it to double the cost.
Yeah, absolutely. So if I take the most basic battery packs are pretty much what you described them, right? And maybe in that case, the cost increment isn't that high. Like you might be like the cells might be 70% of the total battery pack. So you just have like a
Hmm.
sheet metal container, you put all these cells, join them with some materials, put like a very basic electronics and kind of wrap it up. So in that case, obviously, it's pretty straightforward. You might see like a 30% impact on your cost, but most batteries are at least like a much more sophisticated kind of system. And maybe I'm referring to like, let's say, passenger cars and trucks and buses where you have a cooling system with the battery. You have like very good electronics. You might have a sophisticated IoT system which is transmitting. You might not use like a sheet metal system. You might use aluminum castings. So all of those essentially give rise to slightly higher costs, but also a much better final application of those cells. So it also is a lot more valuable for you to basically make sure that those cells connect in the best possible way. And when I say best, it means electrically, mechanically, thermally, all of those kind of combinations should be what I say optimal. And that might vary from application to application. But if I take five different companies, they'll use the exact same cell in potentially five different ways. And it's not completely obvious that the impact of all five, let's say, different designs or different engineering systems will be the exact same. They might be close, but not same. So I think that's the big difference. And cell to pack, which is what I'm referring to, is basically getting cheaper and cheaper. So cells are becoming a larger and larger ratio of that entire cost. So you'll see China basically with LFP essentially is literally just stacking cells together and just bonding them together and putting them in a box. So that in the future is going to become 70-80% of the cost. But I'd say there are today not like complete clear ways to do that. So you also have cooling systems and other materials which basically add some cost.
Okay. What China is doing with LFPs doesn't need cooling system. That's why the
Some
cell
applications,
is
yeah, I'd say like
okay.
not all applications need cooling systems. If your discharge rates are low, let's say like you're running slow speed electric vehicles, like you're running e-rickshaws, or running like a small car, like say like a Comet level size, maybe your power ratings aren't that high, maybe you aren't fast charging it. So yeah, you don't really need a cooling system, but you will see impact. Like if you're operating in 45, 50 climates, you will see some derating on your power. You will see those things, but again, those are edge cases which let's say lower cost products are okay dealing with. But if I take, let's say, like again, let's take Tesla for an example. They're essentially using a really complicated serpentine cooling system. They have, let's say, a very advanced BMS. They're using a polyurethane foam compound. They have like castings around it. So yeah, it's just upon application essentially. Like even a Tata Nexon pack for that matter, pretty well engineered. It has a serpentine cooling system. All of those are then adding cost to basically make sure your cells then give better performance over time.
Okay. What is the difference between a premium cell and a non-premium cell? Because you said you can get a cell with $30 per kilowatt hour, going all the way up to $120 per kilowatt hour. What do you get when you pay more?
So, three things. You would essentially first get better power. So, for the same size and for the same form factor, so if I take, let's say, 21700, which is a common form factor, it's a 21 dia and then a 70 length. Within that form factor, I can see 10 different companies which will have very, very different power ratings. So, if I take, let's say, Formula E, for example, there is a certain cell company out of Taiwan which mainly supplies for that. They're extremely expensive cells, and what they're putting inside it again is a certain secret from their own perspective. But it's a very, I'd say, advanced version of NMC chemistries where they're using, let's say, more nickel, more cobalt, more essentially like doped materials to essentially increase power and energy output. So power, energy, and safety is power, energy, and life cycle is what I focus on. Safety is another one which will come to fourth, but I can go all the way to a very, very advanced version of this chemistry, which is LTO, which is a lithium titanium or titanate oxide version of the same lithium chemistries, which you can now basically be touching $600 a kilowatt hour. But what you're getting is again absolute magic. You're getting like 10, 15,000 cycles while fast charging within 10 minutes. You're essentially able to push the entire envelope to a point where, like, yes, batteries make perfect sense, right? But what you're paying for is mainly in cost and then in weight. So all of these factors basically can keep adjusting to give you different combinations of cells. So you might have something which, let's say, what they call cycle life, give you 5 to 700 cycles, which is basically I charge discharge once, so that's one cycle. And for most applications, that's not even 2 years. Versus I'm using, so that's maybe $30, $40 a kilowatt hour. Versus I'm using like lithium titanium oxide, which is $600 a kilowatt hour. I put them in buses at the airport, which now is super safe. I'm like completely sure they can never ever go into any kind of scenario. And I'm charging in 10 minutes, and I'm charging this for 25 years continuously. So yeah, it really comes down to applications and how you're financing these costs. But yeah, lithium is just amazing. Yeah? Like you have like a whole spectrum, and I think what most people, I think, don't see is the fact that today, if we really had to implement at scale, all of the tech is already kind of there now. I know there's a lot of talk of like moving to sodium or to moving to some alternate form of solid state electrolytes in the future. And all these are great. But today what we have is doing pretty much everything. Like there is very few applications, and I'd say like those also going into like mining and construction and these really edge case applications like ships, maybe planes, which today need better chemistries for. But 90% of automobiles and static energy storage systems can be solved for today with most of the variants of lithium that exist.
Okay, okay. Okay, so I understood difference between a premium cell and a non-premium cell. So what you're saying is while the storage might be 1 kilowatt hour in both a premium and a non-premium cell, but the power and energy output can vary. Uh, Power and energy are the same thing, or what is the difference between
Well,
them?
energy is basically the kilowatt hour, like you mentioned. So that cell
Hmm.
has 1 kilowatt hour, so it has 1 kilowatt hour of energy.
Hmm.
Now, how much time I basically extract that 1 kilowatt hour in is basically power. So if I finish it off in half an hour, that's basically double the power of when I finish it off in 1 hour, which is half than if I do it in 2 hours. So for a certain kilowatt hour, how much time I basically use that to extract this in basically is power. So yeah, just power over time is energy. Energy. Yeah.
Got it, got it, got it. Okay, okay. So with a premium cell, you have the same storage capacity, but you have more power, which means you can drain it faster if you want to.
Yeah, absolutely. That's one very big advantage, and you might even have like certain cells where for the same size, one has more energy for the same power. So like I might fit, let's say, 2 kilowatt hour in that size, so that I might be paying more for. Like let's say I want to build, let's say, like a bus basically. So Tesla, for example, uses a certain chemistry of cells which have very, very high energy density. So you're basically storing a lot more energy in the same weight versus like some other company would basically use an LFP chemistry, which has lower energy density and therefore storing a little more energy. And what that eventually impacts for the customer is range. Like how many kilometers is equating to how many kilowatt hours, which is then equating to, yeah, just range being.
Okay, so miniaturization is the other difference between premium and non-premium. Like if you want miniaturization, then you need more premium cells, and the cycle life, like how many times it can be charged and discharged, would be the third difference between a premium and a non-premium cell.
How energy
Uh,
life, yeah, 100%.
okay, okay. You said the key thing is that cells connect in the best possible way. Is this rocket science or like
I mean,
I
it's
mean?
come from there, to be honest. I'd say, yeah.
Okay.
I don't think it is anymore. I think it's become pretty standardized now. So if I take it from like a very basic perspective, somebody sitting in like a garage or at home can develop a battery pack, right? Like I take cells, I like just like join them electrically, like with some spot welding or just a solder for that matter, and basically make a battery which I can operate. So the concept of a battery pack per se is not very hard to make. I don't think there's anything rocket science level in that. But what does become rocket science is if you start trying to develop batteries for that kind of application. Like if you're developing it for a rocket or you're developing it for aerospace or for high-end automotive, then it starts to get more and more complex. And it's like any engineering, like at the lowest possible level, like if I'm basically just using a
But
screwdriver, there is nothing. But I
why
can
does
go.
it matter how cells are connected? They're
So
all connected to each other, or there's like cell one connected to cell two to cell three to cell four to cell five, which is again back to cell one, or like what is? I mean,
no, so essentially you'd have to there's connection methods. So mechanically itself, I'll actually do certain techniques. So there's 4 or 5 major techniques which people use. So there's spot welding, where people are actually like literally like when I weld two metals together, I'm literally coming with another metal and welding it. Then I might laser weld them. I might ultrasonically weld them. So I can keep getting more and more complex in how I weld them. And this basically then impacts your strength of bonds, but more importantly, your actual speed of manufacturing, which is a very, very large problem for batteries. Because today, what stops scale for anything from an EV and energy storage perspective is how fast can I make batteries, like battery packs. So joining techniques and how I do it, how I'm electrically kind of pulling power out of them, like how is my electrical connections happening? Because if I have like 2,000 of them, I'm pretty sure if I put 10 people in a room, they can all come up with different ways to connect them. And when I say different ways, It's basically even as patterns and combinations when I'm connecting voltage in series, I might have different flows of electricity. So I might start from here, make a U-shaped flow, I might make a back to front. I might like break it up into four what we call modules essentially, and then connect them together. So battery pack engineering keeps getting more and more complex as you have more and more cells. So if I only had one simplest thing to do, electrochemistry problem, just basically put the cell. If I have 4,000, 9,000, all of these then get more and more complex to basically put together.
No, but why does it matter whether you do a U or you do modules or like?
Right. So essentially comes down to how you're basically pulling current, right? Like how you're pulling power. So essentially power is voltage over time or voltage into current and over time essentially and over a certain path. So you're essentially basically fighting resistance and inductance. So the longer your path, the more the resistance is. I could use aluminum, I could use copper, I could use a lot of copper, I could use very little aluminum, I could basically join them with nickel. So there are multiple ways to do this, and they all have their own impacts essentially on what the final product would be. So if I took even two wheelers, for example, if I took a Ducati, let's say, or I took a Triumph automobile, I would have like copper wires basically ultrasonically bonded together and use the finest copper, join them as close to the cells and use the shortest path possible. So that's an entire engineering technique. Otherwise, if I'm doing like an e-rickshaw, I'd basically just spot weld nickel in some basic configuration so I can just pull power somehow. So yeah, it just keeps getting more and more complex into mechanical and electrical. There's a thermal element to this, but that's its own separate thing essentially.
Okay, understood. So you're saying that the resistance, which is decided by the material you're using, is one factor on cell connection optimization. Second is the path, how long it has to travel, is the second factor. And third is how fast can you put it all together. Like these are the three
Yeah,
factors
absolutely.
which.
That's a good way to summarize it. Yeah.
Okay, okay, got it. Interesting. Um, what is BMS?
Right. So it's the battery management system and essentially becomes the heart and kind of the brain of this whole exercise, right? So if I have, again, just one cell, no need for a battery management system. I'll just have some kind of system which is pulling power. What I will need a battery management system for is when multiple cells connect together and basically form a system. So if I have, let's say, like few hundred cells or a few thousand cells, what is looking at all of these cells and trying to figure out what's actually happening? So should I be pulling more power from here? Should I basically like how am I monitoring temperature? How am I monitoring voltage? Are all my cells in the right kind of window? Are they safe? These kind of decisions are basically being made by one kind of electronics board, which becomes the BMS.
Okay, okay. So a BMS has an embedded software in it, which is able to route power accordingly and decide which cell it wants to draw power from, and which is also reading data. Like there is some sensor in it which is able to see heat and stuff like that, heat and how much charge is left and things like that.
Yeah, absolutely. Yeah, the embedded software is a pretty great way to put it. So it has microcontrollers. It has a whole like wave of circuitry, basically analyzing current flow, analyzing different voltages of all the cells, analyzing all the temperatures of multiple cells, and then basically calculating and computing what and how it should basically, let's say, pull power from the battery, and then basically give it out to the final system. So if there's an external kind of contamination of some sort, or basically something happens from externally, electrically or mechanically, all of that essentially impacts this.
Okay, okay, got it, got it. Okay. um I don't know if you heard about Log9 facing some problems because of their technology choice. Can you help me understand what that was?
Yeah, so Log9 basically essentially was deploying a lot of LTO packs when they had initially started. And LTO is essentially the lithium titanium oxide chemistry we spoke of, right? And Log9 is one of the companies essentially that had become pretty upfront about like actually kind of executing this across different automobiles. And they were one of the first companies to do that. I'd say two wheelers, some of the e rickshaws they did, and even some of the smaller buses, they were also responsible then for financing some of those batteries. And the issue here is the cost and then the time it takes to recover that, right? So you're essentially in a 10-year lease for a specific system. And that is an interesting choice to make for a market that's moving this fast, right? Like you're essentially changing lithium forms every year. So to basically get into that long-term lease, I think is one of the major reasons I think LTO hurt them. But that being said, the actual output of that system, like how fast you can charge it, what it can do in terms of life cycle, is amazing. Like you can get 10 years life, you actually can get 12 minutes charging without doing much on the pack level, because that chemistry is just so robust and so specifically designed for just doing this, that yeah, there is really no doubt from a technology perspective that there was anything kind of stopping them from scaling. The hard part is, in a market as dynamic as the EV sector, especially in India, for the applications that we're going after, which is light mobility, and in the pecking order of automobiles, I would put light mobility pretty low, right? Like it's not like buses or like Tesla cars going up. And so to put LTO in an application like that to then be able to finance over 10 years, I think is a big roadblock. And I think a lot of people have learned from that. So LTO, if I see, has kind of disappeared quite aggressively from two wheelers. Most of them have still continued to use NMC, but some of them are also now starting to switch to LFP. And yeah, I'd say that yeah, it's a huge burden on a business, right? Like, because I'm trying to do, let's say, 20 crores of business every month. Within 12 crores, I've racked up 240 crores of debt now. So, and financing that over 10 years, and financing that every year. So you're essentially looking at 250 crores of debt every year, which then has to grow 30% every year. Yeah, that's a hard one.
Okay, so it was like a PMF problem. They had a good product, but the fit with the market was not there. Such an expensive product would not work for the kind of market which India has for EVs, and I think most people don't even expect the vehicle itself to last for 10 years. So, like a 10-year lease for the battery is definitely a question mark decision. Got it. Interesting. What is the difference between NMC and LFP? You're saying that most light mobility means two wheelers and e-rickshaws.
Yeah, I'd say three wheelers too. So actually today, NMC essentially is better energy and power for the same kilograms. In certain cases, mainly energy. Power, I think, is basically matched now. But for the same weight, I would essentially get more kilowatt hours out of the same battery pack. And now that's very critical for two wheelers, because I only have a certain finite amount of space. So I can either put under my floorboard or I can put under my seat. And now within that space, I have to basically get basically a certain amount of power and energy, essentially. So I'll have to derive 1 kilowatt hour, and then I have to derive maybe like few kilowatt from that same thing. So if I see the spacing and the fitment within a vehicle, NMC just always puts at least 30% more energy, which then translates to 30% better range. Now, this problem is not so common in e-rickshaws, where I actually have the space. Like, I have the weight, I have all of the kind of ability to be able to use LFP without any impact to rider. But in two wheelers, where I might have to remove the pack and carry it home, where I have to basically always hit like 120 kgs on a vehicle level, that then drives people to use NMC. So Ather, Ola, TVS, Bajaj, even Hero for that matter, all use NMC. Potentially will use LFP in the future because it is improving pretty significantly. But yeah, I'd say today the main reason is the portability and the ease of basically getting a better, yeah, watt hour per kg.
So what I hear is that LFP is fundamentally a better technology, but currently NMC has an advantage of miniaturization. Why is LFP fundamentally a better technology?
I'd say it's better in two main regards. So, specifically for India, one of the big advantages LFP gives is that the actual temperature that which it becomes unsafe at is a little bit higher. So, NMC starts getting unsafe at around 60, 70 degrees. So, if you don't manage your system well and if you don't have a strong battery pack, you are going to face certain issues. Whereas LFP can also have those issues. There is no lower risk of fire, but those issues start at around 80 degrees. Now, that 10 15 degrees is enough of a window to basically give a certain amount of breathing room to a manufacturer. So, it allows most people to, I don't want to say design their battery pack poorly, but it is more tolerant to a poor design or to some form of just basic engineering. That is one advantage LFP has, and that's specific to India. The other reason I'd say it's better is only that China has just dropped its cost so much that it's hard to really see how everything won't become LFP. Like today, NMC in most scenarios is around 10 to 15% per kilowatt hour more expensive than LFP. So yeah, I'd say cost, and yeah, mainly cost is the big advantage. For that matter, like power, energy, in some cases NMC is also better. You'll see like most like eVTOL or some small planes or even performance cars will continue to use NMC, but most basic applications and even basic cars are switching pretty much all the way to LFP, mainly for cost. Yeah, and that is the big driver for this market. So yeah.
Okay, so LFP is cheaper, even though not as miniaturized, which and more tolerant of heat, which makes it better for Indian conditions. Um, I've heard about BYD doing some really cutting edge battery technology stuff, really game changing stuff. We've talked a lot about what has been happening so far. What are the trends which you see going forward?
Right. So the three big things that are happening now is one, there is a constant push to basically charge faster. I think there is a lot of work happening on the anode side to basically improve retention of lithium. And essentially, what that translates to is when I'm charging very fast today, the big issue is that I'm seeing deposition of that lithium happen, and it's creating like this hard layer over time. Like if I keep trying to like basically pull something back and forth from a layer, you're going to see something stick around. So how do I basically make a scenario where I can make sure that all of this lithium is basically always going and coming back? Like so I give it 100% retention. So there is a lot of work that not just BYD but pretty much every cell company is doing on figuring out better anode materials. So silicon is a new trend. Silicon anodes will become more and more common. Even it's already happening where some anodes are starting to get doped with silicon. The second big trend that's now happening is the electrolyte itself. So this has been a pursuit for as long as batteries have existed, is to turn the electrolyte into a complete solid state. So today electrolytes in batteries are basically kind of a gel, so liquidish gel basically. And the biggest issue that creates is safety. So now that you have this kind of movable electrolyte, it creates this risk of basically joining the cathode and anode together. Like you always have this risk that the separator might get torn, the electrolyte will like basically create some leakage in this path. Creating that into a solid state basically guarantees that electrons are basically flowing through a medium which is just fixed in nature and that's never changing. So that volatility is basically gone. So making your battery pack that much safer and that much more tolerant. And then the last one I'd say is just going to be alternates to what today are. Like, so producing, let's say, better versions of lithium. That might be 10 different things, to be honest. Maybe potentially switching to sodium for better cost, switching to versions of lithium that allow, let's say, 500 watt hour per kg, then allow them to go into planes, allow them to go into ships. And yeah, essentially just an electrification for pretty much everything will happen only when safety, power and life cycle are solved for, and energy for that matter. And all of these will just go on improving as we go. So you can see a lot of improvement already happening in the BYD blade cells for that matter, where they're like starting to puncture the cells and nothing happens. And that's owing to that better chemistry and that form factor basically being that way. So you'll see that improve. You'll see the cell to pack architecture improve. So yeah, pretty much all the way around, China is doing a lot of work in the chemistry side, and I think a lot of work hundreds of other companies are also now doing on the pack and the electronics side, and even the algorithm side. Like we spoke earlier, right? Like lithium is still magic. Like batteries are still magic. Like nobody really understand. Like I won't say nobody, not enough people really understand exactly what's happening on a cellular level, right? And I think that understanding translating into different algorithms, different ways of charging, different ways of discharging. How do I make better electronics? How do I make this whole system cheaper? All of those will keep happening too. So a lot of work, even for the standard lithium cells, which I call, to basically create better systems out of them is going to be a large focus also, because not everybody is going to have access to the best BYD cells all the time. Those will still go into 2030, all of that. But yeah, you'd see all those innovations on a system level happening right now.
Okay, okay. That algorithm improvement is where India has an edge. Like
Yeah,
traditionally,
it's
software
algorithm
has been our.
improvement, even applications, right? Like today, if I take two-wheelers, three-wheelers, these are applications which China's looked at in very specific scenarios. Like they have amazing infrastructure for their two, three-wheelers, and the vehicles they already supply to India really couldn't do what India's vehicles demand, right? So that's why you're seeing a lot of the vehicles become Indianized now, even the battery packs for that matter. So all of that work will keep happening. I'd say application-based engineering for a lot of these systems, actually improving life cycle for those cells, producing better thermal systems, producing more miniaturized packs for different vehicles. And interesting, a lot of this work actually for ICE happened in Japan, right? Like you take the 80s, 90s, all of the two-wheelers and three-wheelers were derived from Japan. Like even today, the ones that run. That whole work actually hasn't happened in Japan for EVs yet. So I think India has a huge chance to basically create that standardization for this segment using batteries as the kind of key focus. Now, whether the cells come from China, whether the companies set up cell companies in India, that I think is a different stage. But how do we create applications and systems around these standard cells, which then scale globally? I think India has a huge edge on.
Interesting. Uh, what is the problem with fast charging? Why does fast charging degrade? Is it just degrading battery life, or are there other challenges with fast charging?
So degrading battery life is the primary issue, but safety is
Which
also a
means
very
the
big one.
cycles. Degrading battery life means less cycles.
Yeah, less cycles, lesser years than I'd basically signed up for. Like I might have thought this might run 5 years, but now it's just running 3 years. That is one. Safety is a big part of it, and I'll come to that. And then the large one is just usability of the vehicle. And we'll just touch upon all three of these. So when I'm fast charging a vehicle, I'm essentially basically producing more current and more power. So on a cell level, if I went, I'm actually transferring ions much, much faster than I normally would. So this rate of transfer of ions, basically coming back to how the deposition is happening, if I keep going this much, much faster all the time, then a layer will essentially start to create. And this layer essentially hardens over time and then basically reduces my ability to charge, discharge again and again. So this is the first impact. So I basically have degradation and a lower life cycle if I keep fast charging. The second one is safety. So now that I'm forming this hardened layer, I might actually still be basically going on charging. And now this hardened layer can basically poke my separator and actually create a short circuit path now. So I actually have a huge safety concern within my battery if I keep fast charging and I basically damage my cell, which then leads to thermal propagation, fires, etc. And then the last impact of fast charging basically is on usability. Like this isn't so apparent in four wheelers, but this is actually very apparent in two wheelers and three wheelers and some other applications. If I fast charge a vehicle which is not, let's say, designed adequately enough to fast charge, I will then not be able to discharge after that. I will basically hit my temperature limit. I will hit the limit of where that battery is basically exhausted its limitation. And now I might have to wait for an hour, hour and a half for the temperature to go down, for the battery to be able to accept more current, to then which I can then continue using it. So this is actually the very huge impact which users see, especially in hot climates. And this impacts pretty much everything. Like it impacts Teslas too, but much so lesser because they have a cooling system and they've kind of designed with the system in scratch.
Okay, interesting. So you're saying the battery has some sort of a cutoff system if it hits a certain temperature and stops charging. So you have to wait for the battery to cool down before it will continue charging all the way till full.
Absolutely, yeah.
Ah, interesting. Okay. And what is the blade cell by BYD? What is the innovation in that? Why is everyone talking about it?
Yeah, so the BYD blade cell is essentially a standard LFP cell, basically produced in a unique form factor. So what they've essentially done is they've obviously changed the chemistry of the anode cathode quite a bit to basically make it in a system that you can actually kind of keep in that long, thin kind of form factor. But even the construction of it is very different. So they've essentially taken longer strips and basically stacked them instead of creating like a whole roll, which normally cells do. So the innovation here is in construction more than the chemistry here. Like, how do I take a long flat cell? How do I actually bond it? How do I make sure it's stable? All of those are the innovations. And the real advantage of that cell then shows up at an application, right? So in a car, when I want to keep my, let's say, the height of the car low, I want to only use the base. I want to basically use it as much as possible. I can now use a lot of blade cells arranged in a line without much need for other materials and basically form a battery pack. They have actually done quite well in certain vehicles. There are a certain number of issues scaling that battery pack because, like anything, it is a new construction, and cells, when they're rolled and basically created, there is a lot of, let's say, experience and expertise around that construction of cells. So there is a little bit of a climb where they're basically figuring that out. That being said, a lot of cars are already using that, so it does work. There is nothing stopping that. But most of the advantages basically show up to basically see watt hour per kg, basically the weight, the final weight, and the range you get, and the safety element of it. Because since you made it so thin and spread out across a longer surface, the chances of propagation and continuing that are lower. That hasn't been completely proven, to be honest, because I have seen instances, but in theory, that is correct. Like it's basically spreading over larger surface area, so you will basically be able to resist more heat essentially.
Okay, okay, okay. Interesting. Uh, why do EV companies also want to be battery makers? And I think Tesla was possibly the pioneer with the Gigafactory. Have they invested as much in the battery manufacturing as they've invested in their production of Tesla cars in terms of the capital investment? Or
I'd say it'll be pretty equivalent. Like, so the good thing for them is the Gigafactory also pumps into a lot of cells to the energy storage business. So basically, all the Tesla Powerwall there or Mega Pack. But for Tesla, it was also, I'll answer this in two questions. For Tesla, it is very important to do it because being the first company, you have to kind of propagate the entire ecosystem. Like you have to get the customer used to everything, right? So that's why they had to do charging. They had to do literally everything. They went all the way to producing cells, which they didn't initially start with. They were using Panasonic cells for the longest time, but they were hitting a wall in terms of how quickly even Panasonic was innovating on a cell level. And that was really the main reason they started. So they wanted a bigger cell, they wanted more energy and power from the cell. And a lot of the innovation basically didn't come fast enough for their basically needs. That being said, they have also now started to use Chinese cells. Like for a lot of their LFP applications in China are using Chinese cells. A lot of their vehicles in basically Europe and US use their cells. So it is split. So for Tesla, it is very important to be vertically integrated, and you see that in China also. Like BYD, for example, is completely vertically integrated. So the biggest benefit for an OEM is cost and quality, right? Like if I have complete control over my cost, I'll know 100% what's going in. I also have complete control of the factory, so I'll know exactly what quality goes in. That system, though, I personally feel doesn't really work for every automotive OEM. And today, if you see the world, it really is only working for those two. And they're clearly standing out because of that, right? Like their margins are better, their businesses are booming, they're moving at a rate nobody else can move at. I personally feel though in a market that stabilizes, where a market like where everybody is doing what they're best at and now creating a system where the margins have stabilized, in that world, it's not going to be 100% necessary to do that. And that is also playing out in China, where you see CATL basically working with five, six OEMs at the same time and competing head on with BYD. So yes, it's beneficial for an OEM to do all of that, but no, not everybody is BYD and not everybody operates like that, to be honest. And not everybody wants to. I think it's a completely just kind of insane way to operate. Like, I know how they work, like the work ethic and all of that also. And not everybody works like that, to be honest. So, yeah, I'd say it definitely helps, but it comes at a cost. It comes at a very significant price.
Ola also wanted to start a Gigafactory, right? Like
And it's still
manufacture.
doing it, to be honest. They're in process. They're producing prototype cells, from what I know. I know they've already started putting it into certain vehicles. I don't think those are like production ready vehicles, but yeah, their pitch in a way, like at least when they went to IPO, was that their gross margins like significantly improve when they start producing their own cells, right? And again, in theory, that makes perfect sense, right? Like you're already paying a certain premium to import these. But what's also happened in the 3 years since they started producing is interesting to see that the prices of cells have dropped so much and that the duties have also dropped so much that I would be keen to see if Tesla cell, like even when it comes out, will be as competitive in cost, right? Like eventually, if they get to a yield which is high enough, and they're actually like then pumping out cells at like gigawatt hours per month, then sure, like there's nothing to doubt here. But yeah, I've seen the climb for a lot of these cell companies in the past, just having kind of interacted with some of them, and it's a $400 million 5 6 year climb to get to 99.99 some percent, right? And China's whole country's ecosystem was basically furthering all their cell companies to work together and compete together at the same time. Ola is a little bit alone in this, to be honest. And I think it's also like super commendable to see, right? Like every other cell company in India, if you see what they're trying, is basically getting some Chinese company to India and like working with them. Ola is genuinely like fully engineered, like over here, like near Bangalore. So there are obviously inputs from different parts of the world, but they actually have an R&D team. They're actually producing those cells. So yeah, if it works, there's nothing like it. But yeah, just super commendable. But yeah, it's extremely hard. It's insane.
I think possibly, like, in the world of chips, Nvidia is does not manufacture chips. Like, it's TSMC which makes chips for every chip company, be it Nvidia or AMD or whatever, except for maybe Intel. And possibly the reason is because the technology progression is fast. You keep moving from one generation to next generation, and then you need to do a lot of investment. So you need massive scale, and possibly if you are making chips only for yourself, you will not be able to keep up with somebody who's making chips for many players.
No, and that's what's playing out today. Like you see like extreme amount of consolidation in cell companies also, right? Like till 2 years back, there were hundreds of them, and hundreds of them all across the world. Like the US had 10, Europe had like five, China had gazillion of them. Europe has none now. America's left with like a couple of them, which will be interesting to see if they get to scale. China has only two really dominant players, with a lot of other players just serving smaller markets across the world. And it's for exactly what the reason you said, right? Like if I get so good at one thing, let's just keep doing that till I get everybody's market share. Yeah.
Mm, interesting. Okay. Uh, who's the other cell company in China besides BYD?
CATL, they're actually yeah, the largest in the world now. Yeah.
You worked with the two big EV companies in India, Ather and Ola. You've seen that ecosystem maturing. Uh, what is the state of batteries in Indian EV market, especially the light mobility market? Uh, I believe for a long time there has been this debate between swapping versus fast charging and things like that. Tell me a little bit about that.
Yeah, absolutely. So today, if I say the market's actually pretty split open, right? So if I take all of the consumer-based vehicles, like if I take Bajaj, Ather, Ola, TVS, all of them are primarily charging focused. Like they pretty much every vehicle comes with its own charger. You can plug it into a socket and take anywhere between 3 to 8 hours based on what kind of power of charger you use. And that is the dominant way of most consumers using their vehicle. The problem is that is usually the first leg of EV scale. Like in the beginning, when you're essentially starting to scale, only certain people who have, let's say, a company charging their homes or have a very, very specific way to charge it, maybe their office or some location, can continue to doing it. But once you get to a very large ecosystem, the fueling pattern that you're seeing today with ICE vehicles has to be replicated in one way or the other. Now, one of the most dominant ways in the last 10 years, especially for two wheelers, has become swapping. So, this started primarily with Gogoro in Taiwan, where they essentially built up an entire two wheeler vehicle company. They built up the entire swapping ecosystem around it. And basically, you open up your seat, pull out a battery, stack it into a station, pull out another battery from that station, and then put into a vehicle. So, what you put in was at 0%, what you get in is 100%. So, you get a certain amount of range, usually like 40, 60 kilometers per battery, and then you're essentially good to go. And then these stations are usually spread all across the city, so you can use them at your ease. Now, in theory, this is the absolute best system there is, right? Like this, in terms of convenience, in terms of actual usability, replicates fueling to the most, like to the most time like use case possible, like 2 minutes, both. Yeah. But the issue here is that on paper, and we've not seen this happen yet, and potentially is possible to do in India, which a couple of companies are trying. The unit economics of this don't work as well as they should. And primarily, it comes down to the fact that all of these swap stations require a significant amount of capex. You have to set them up in public areas, you have to set them in areas where you can get high power. Potentially, some of these need to be air conditioned to keep them at the right temperature. And over and above that, if I have 100 vehicles in the market, I at least need 30-40% more batteries. So essentially, paying for those extra batteries to be sitting in these stations also. So all of these things combined, plus the amount of capital it takes to scale this, right? Like you need to basically be putting swap stations all across the country, is always going to be more excessive than if you were to just do charging as an ecosystem, because I'm just connecting the same charger which is in the swap station basically directly to the wall and using my vehicle. Now the issue is again that the time of charging is too large. But if that time of charging could, let's say, instead of 3-4 hours, basically be like a 20-30 minute charge, this changes everything now. You basically improve that rate by almost 10x. And you're now in a system where, okay, even if swapping takes 2 minutes versus a 20-30 minute period, the actual unit economics could allow your system to be so much cheaper over time that it's most likely going to be in a situation that a consumer will prefer it. And this is the actual mentality Ola and Ather also took. Like Ola and Ather both typically used to be a little bit anti-swapping because of all of these redundancies you have to create within the ecosystem, like extra batteries, extra stations, extra everything. I don't know exactly how much I basically invested in, right? Like I'll never know. Like I'll always have a little bit more. And sadly, this has also played out for Gogoro not the best way, because if you see them over the last 2 3 years, the amount of batteries they're basically adding versus the amount of OEMs and vehicles they're able to add is a giant difference. So it is always going to be like a kind of catch up game where you're always trying to convince more OEMs to come, but you're also trying to sell, but also setting up more capex. So from a conceptual perspective, if fast charging works and works fast enough, then it makes perfect sense. But the problems have always been that fast charging has been actually pretty slow, like it's 1 to 2 hours. Plus, the impact on life and the actual impact on my TCO and the impact on my usability of the vehicle is so high that I really can't be doing it again and again. So the holy grail here is, can I charge fast enough for the lowest unit economics and then actually get good life? So if that actually happens, I feel like swapping obviously then is a little bit of a transition solution. Now, this hasn't necessarily been the case in India, where you see there's 3 4 companies scaling very aggressively across the B2B sector in two-wheelers, also scaling e-rickshaws, where, because till recently, I'd say till like 1 to 2 years back, it really wasn't possible to fast charge any of these products. But in the last couple of years, a couple of companies in India and even few companies globally have started to like fast charge these vehicles. And I feel like even within that, there's going to be a lot of approaches. Like, what will be my ecosystem? How will I set up these chargers? Where will I set them up? What kind of chargers? What kind of batteries? All these questions will then result into different decisions companies make, which then give rise to different solutions. So I don't think it's a complete yes and no that okay, fast charging is better than swap. There are certain applications which potentially swap can keep continuing, like China is swapping truck batteries, so maybe that's the right way to do it. But I personally feel for a market where unit economics matters, where total cost of ownership is my only focus and convenience is secondary, their fast charge makes perfect sense. There is like no question there at least.
Okay. Um, so the hit on total cost of ownership by fast charging is essentially the battery life going down.
Absolutely, yeah. You're essentially signing up for 3 years, but only got like 1.5, 2 years. So if there were companies who could essentially maintain their 3 years or even extend 3 years, yeah, it's an absolute no-brainer to be fast charging.
Okay. And just for my listeners, I want to clarify this concept of total cost of ownership. Um, the This concept was essentially born as a way to make EVs look favorable in front of ICE vehicles, because in an ICE vehicle, you are typically paying less than an EV vehicle, but in an EV vehicle, you are saving money because the cost per kilometer is lower. So, uh, just to make an EV look more favorable, you look at the total cost of ownership. Like over a 3 year period, if I ran an ICE vehicle for 1 lakh kilometers, I would pay cost of vehicle plus cost of fuel for 1 lakh kilometers and service and maintenance. Whereas for an EV, that same thing, while the cost of vehicle might be higher, but the cost of energy and service and maintenance would be much lower. So over a 3 year period, the total cost of ownership for an EV would be lower. And therefore, this term of total cost of ownership is a standard term used by the EV industry. Just as a clarification for listeners. Okay, so you're saying that there are B2B companies which are going all in on swapping. Which are these B2B companies?
Yeah, absolutely. So Sun Mobility, Battery Smart, Yulu are obviously the big ones today. They're basically doing two and three wheelers. Sun Mobility also does much larger vehicles. But yeah, across the three of them, they have pretty much done like millions of swaps. Yeah. The idea is that Battery Smart is scaled across e-rickshaws very aggressively in the north. Sun Mobility
Battery
has
Smart is doing vehicle plus battery or only a swapping service?
they do a swapping service. So in fact, they today purchase batteries and charges from different companies and work with different people to do like a franchise model for swapping, where they're essentially more of the platform, the operator for swapping, but
Okay.
not really so much the technology behind swapping.
Got it, got it. And Sun Mobility?
Sun Mobility is actually both ways. So Sun Mobility has an integrated tech stack where they have the battery, the swapping station, and the entire electronics behind it is in-house. And they're also responsible for setting up those stations and providing those batteries to multiple fleet operators or different companies, essentially. So they're more end-to-end per se. Yeah.
Okay, okay. And Yulu, of course, is like for gig economy workers who want to rent a two wheeler. So they, for them, like battery swapping is how they uh, recharge it. Okay, got it. So now what you're saying is that fast charging, practically, even with solving the life problem, like the life degrading, even if you solve that, it'll still take 20-30 minutes, which is not a petrol, like a petrol fuel kind of an experience, which is a 2-3 minute experience. um, but fast charging is significantly cheaper, especially for fleets, where you have high usage of vehicle. And the reason why it's significantly cheaper is because cost of the fast charging station, is much lower than the cost of a battery swapping station. Because for a fast charging station, you just need that fast charger. That's it. That's the only investment you need. Plus, of course, electricity is like the operating expense. Whereas for a battery swapping station, you need whatever, like 100 batteries to be installed there in that station. What is the approximate difference in capex for battery swapping station versus fast charging station? Like, is it like a 10x difference, or?
I'd say it at least 4x. Like for the same capacity, for the same number of riders, it at least is 4x. And the one big caveat here also is that it's actually when you're operating a swap station also, like let's take Yulu as an example, right? They're literally taking rental for an actual shop where they're like fully air conditioning that shop and like setting up the station inside the shop. Whereas, yeah, for a charger, I can literally just set up like these poles pretty much all across the city, essentially.
Okay,
And
so the operating expense is also much higher for a swapping
yeah,
station.
and
Okay.
even one stage beyond that, just to maybe elaborate on the time part, right? Like, so 20-30 minutes for most use cases, I agree, is still a lot of time, right? Like, you will still basically see like that mindset of doing, let's say, like a 5 minute petrol refuel. But today, specifically, the use cases we go after are actually solving that while doing their downtime. So we can come to that. But the idea is basically how do you design an ecosystem where now I start to use a vehicle like a phone, right? Like nobody knows how much time a phone charges in. Literally, I
Mm.
can guarantee nobody knows a full
Yeah.
charge of a phone
True,
how
true,
much
true,
time
true,
it takes,
true.
right?
You sporadically charge it. Yeah,
Yeah,
true, true, true.
that's the intent here. Like how do you
Uh,
start using a vehicle like a phone? That's the intent.
uh, Very interesting. Okay, that's a good way to put it. Okay, so this is essentially the problem that you have set out to solve at EMO.
Yeah,
Uh,
absolutely. Yeah, this is one of
Reduce the cost of energy, like essentially build the next generation HPCL and Indian Oil and BPCL. So the next generation of these will be companies which are providing energy to two wheelers. So is that what you're building at EMO?
Absolutely. That's definitely one part of it, right? So, today for quick commerce, which is the segment we've started, and last mile mobility, which is the broader segment that we're working on, actually providing the energy as a service, basically getting to the point where you can now start guaranteeing to the user the actual cost of every unit of electricity. That really is a long term focus for EMO. So how do we basically more efficiently use our batteries? How do we connect them more efficiently to chargers? How do we make sure that the chargers, wherever it's taking from electricity from, is the cheapest electricity you can get? How does it manage that over the day? All of those problems then basically finally impacting the life of the battery and the total cost. All of those problems is what EMO is solving. And we're starting with last mile, like I mentioned, but then the intent is to go much bigger and basically take up multiple applications as we go scale.
Okay. The things you mentioned, the charger, the battery, the things which you're solving at EMO, the charger, the battery, the lowest cost of energy, like to charge that. These are the three broad things which you're solving.
Yeah, absolutely. Yeah. The interplay between the battery charger and then the entire service around this whole ecosystem. Yeah.
Let me start with lowest cost of energy. If I have a charging station in Bangalore, isn't the cost of energy set by the Bangalore, whoever is running the Discom, Bangalore Discom distribution company? What is the way in which you can reduce that cost?
Right. So today, if I basically take any one specific charger in Bangalore, right, like you'd essentially be paying a certain unit rate for electricity over the day. But what's happening is if you essentially go through your whole bill, there's a lot of line items. So there's time of day, time of season. You'll basically loads from where you pulled the power from, how much over the commercial limit you pulled it. So there's a lot of impacts of all of these small things which basically impact your final electricity bill. So
You're saying the Discom doesn't charge a flat rate, like 10 rupees per unit flat? That's not the way how it
no,
happens.
that's going away. So there's a lot of like plus minuses based on the day timing, plus minuses based on the season, plus minus based on your location, even you're based on your amount that you're consuming. If it's basically over a certain load, All of these things impact your final bill. And
So
this is
it's like a surge pricing. So you're saying discoms have surge pricing?
surge pricing pretty well defined in a way, but
Mm.
different state to state also for that matter. Like different states might have their own way of doing this, which will then basically impact my price of electricity in Gurgaon very differently from what it'll be in Bangalore, for example. And the intent for any high tech business is to standardize the energy cost in the future. So quick commerce being one of those that rely very heavily on moving energy from point A to B is going to kind of be defined by what their cost of energy will be in the future.
Okay, okay. So, like basically, the non-peak hour usage of electricity will be cheaper, very simplistically speaking.
Absolutely. And even for that matter, like, can I set up solar somehow there? And can I use some of that? What time of day do I charge that solar at? What time do I charge the battery at? Like, all of those combinations now behind the charger will actually lead to a lot more savings. So, what the intent for EMO is that we're already collaborating with a lot of commercial establishments which have fast chargers outside, but have a battery and solar as part of that establishment. Basically, to now do all of the energy buffering and the energy transition back and forth from the vehicles to the grid.
Okay. Uh, is it worth it in terms of the savings? I mean, if you're saving uh, like 5-10%, it may not be worth it doing so much, like installing a battery, installing solar. What is the possible saving that you can get by doing all of this battery and solar and all?
So the savings today are a little variable based on where you go, but I already know that there are companies now using solar with battery and pricing electricity at less than 5 rupees a unit. This is almost impossible to do if you basically pull from the grid. Like you're pulling it 8.5 to 14 rupees a unit for most cases when you pull from the grid. And the idea is that even in some states where we're working, off peak power is at 3 rupees a unit, on peak power is at 10 rupees per unit. Plus, even in places like Mumbai, for example, it's plus minus 1 rupee per unit. So I might be paying 9.5, and for 2, 3 hours a day, I'm paying 10.5. So it's not 5-10%. In fact, a couple of the businesses we're establishing these kind of energy storage systems for, you can see a 30-40% improvement over just over what you had just using batteries and very small amount of solar. So if you are really able to like size your solar battery charges really well, I'd say easily 40%, and while making that return back within a year. That is really the focus here. And that's how big this will get, because the future also allows you to do a lot of energy trading now. And this is a whole new world that will open up in India, right? Like where multiple people set up microgrids and sell and buy back energy back and forth. So now you're essentially fighting for paise over time, which then accumulates to a lot over, let's say, a year. So, in fact, a very large mall in Mumbai who we were working with, we essentially saw their bill was 1.7, 1.8 crores a month. And even just by doing time of day, time of season, some wheeling loads, putting a best there of a megawatt hour, we were able to see like a 10-15% improvement in their bill, which, if you take over a year, is actually more than what it basically cost them to put up the additional capex. So, yeah, I think it's going to be huge.
What is the best? You said you put a best of one
Sorry.
megawatt.
A battery energy storage system. So it's basically like a battery basically put into a system where you can now, yeah, use that as a static energy storage system.
Okay, interesting. Okay, and by energy trading, you mean like say in the non-peak hour, you can draw energy at 3 rupees a unit, and in the peak hour, you're drawing it at 9 rupees a unit. So you can draw and store energy at 3 rupees a unit and sell it back to the grid when the grid is at a costlier level. Maybe they'll not buy at that 9 rupee, but they'll buy definitely at much more than what you paid for it initially.
Right, absolutely. Yeah, no, that's absolutely. And in the future, the intent is that you could sell it to someone else. Like, because once the whole energy trading microgrid markets opening up in the next year, so opens like it's already there for large amounts of power, but the intent is to open it up for everybody, and that will be huge then. Yeah.
What is this? Is this a regulation? What is
Yeah,
this?
yeah.
This
So
microgrid? Yeah.
the regulation today is that if I basically have a solar farm and if I have above a certain amount of power, and I think that keeps changing, but it's around 200 kVA right now, I can basically sell back to the grid. I can produce that power and sell it back. And if I'm in a certain scenario, even above a higher value, I can sell it to someone else also. So as a private entity, I can sell it to another private entity at any predetermined cost between us. And then that allows a scenario where once this power level drops, let's say like maybe 50 kVA or 100 kVA, or even if it's 1 megawatt, multiple people will have their own small solar and battery farms to basically produce and then sell electricity. And that will basically be a game changer to, let's say, how even the grid works overall.
So, like for the equity trading market, you have SEBI as a regulator, and you have NSE and BSE. What is the equivalent for this energy trading market? Like, is there a regulator? Are there exchanges? How do these deals happen? And how is the energy moved? Who's running the pipes? And just a little bit of a diversion from our main topic, but I'm just curious.
No, so there is an open exchange forum. I don't think there's anything as clear as like an NSC for this. It is forming. So a couple of entities are doing it, CESL, and a couple of entities are, let's say, focused on this. But it's essentially very clear on a discom level. So usually discoms trading. So that's become pretty straightforward. But there are, I'd say, interfaces people are setting up even on a national level as we speak to mainly expedite this in the future. So there are a couple of companies doing that. Which interface actually picks up and then becomes a standard will be interesting to see. But yeah, it's in process, I'd say.
And the pipes would be these power transmission companies would be running the pipes, or even the discoms would be running the pipes, which allow the trading to happen between two private entities.
Right. So the interesting thing is a lot of this today actually is completely virtual. So I'm basically like producing and selling it back fairly virtually. So the piping system is pretty common when I have like actual solar banks near a grid where I'm actually producing and helping it. But a lot of this is that, okay, I am, let's say, a giant institute. I have my own solar. I took that solar and basically sold it somewhere to some discom. And now I'm buying from this discom here. So I don't actually physically transfer that, but I'm basically balancing it out virtually.
Ah, got it. Okay, right. Okay, interesting. Okay, so this is one theme that you're solving: lowest cost of energy. Is this sold as a service or as a asset? Like you price it as an asset, which means that you charge whatever 5 lakh rupees to install a BES, and that's how you earn, or do you sell it as a service where based on every unit consumed, whatever? I mean, how do you price this?
Right. So today we actually do both. So for a lot of the applications, I'd say, so let's take two wheelers as an example. So today we have Domino's, which we work with. Domino's actually buys full products. Like they're not really very interested in the service part of it. They run the service themselves. So they are actually buying vehicles that are already fitted with our batteries and then using fast chargers that are already installed at Domino's stores to basically fast charge those vehicles. So in that scenario, we're more usually just selling these outright to a vehicle OEM, which establishes a solution and then gives it to the end user. But in a lot of these where we're working with quick commerce companies like Blinkit or even BB now, the intent is to basically give a flat rental to the rider or to the fleet operator, which then covers everything. It covers the access to the vehicle, to the fast charger, to the battery, electricity for that, communication, access to the app. It's a flat monthly rental which the rider is paying, and that goes through us. We are essentially responsible for the energy portion, but we are facilitating this whole ecosystem because all of this revolves around the concept of fast charging, the concept of setting up fast chargers within the dark store itself and operating this as a new model. So in the future, we see this becoming a system where we are selling assets to different parties, where we, let's say, sell chargers and energy storage systems to dark store owners, and they run this, and then we sell batteries to OEMs and fleet operators. But today we're doing a lot of this to basically promote and actually propagate this all over the country, because actually creating this ecosystem has a lot of moving pieces, and then the entire ops for it and actually scaling this for the first at least 1,000 dark stores, even for the first 10,000 dark stores, doesn't matter, we're doing it. Beyond that, we see a lot more people getting involved because the problem has always been the asset reliability. Like the reason EVs aren't scaling, the reason this is not becoming a norm is that, right? Like, how do I make sure I can use this for an exact amount of time and get the return I want? So we see more and more people becoming partners with us long term. But today, yeah, we're essentially doing both sale and service.
Okay. Okay. Um, how much revenue do you make from outright sale
So
of
at least 80%, I'd say
BES?
70% of our revenue is coming from outright sale. The idea is that the leasing revenue is scaling pretty consistently because yeah, it's accumulating over time. But we do almost 1,000 batteries a month, and yeah, our cost for the batteries will vary anywhere between like 12 to 17,000 rupees per kilowatt hour. So we're scaling from 1,000 packs a month to almost 1,500 packs a month in the next month or so, and that's a pretty consistent climb for us.
So what you're selling is a battery, a BES, which is a battery energy system,
Right.
uh, which includes batteries and solar if needed. Besides that, you also sell battery standalone for vehicles, and you also sell chargers. These are the three things that you sell.
Yeah. Yeah, absolutely. And all of these actually connect on our software, which is the one big part. Like it's a full energy kind of management platform, which not only today is scaling for our packs, but is actually now starting to scale for other people's systems also. But we are essentially responsible for batteries end to end. Chargers are obviously a big part of it because they are the kind of portal, but all of our innovation and most of the team's focus on R&D is basically how do I maximize battery life and how do I make sure that they keep getting better charge rates over time and get more power over time essentially.
Ah, okay. So I guess the way to understand EMO is battery as a service, is the long term model. Currently, it is happening through asset sales, but long term, it will be battery as a service, which would need you to handle the charger, the software, the battery itself, all of these things you would handle at your end. Um, so, do you also manufacture batteries then?
Yeah, actually, we have our own battery pack assembly unit near Bangalore today. We essentially today only buy cells. Pretty much everything else we fabricate from scratch, like all the plastics, metals, the electronics, the sensors that go into it, the entire firmware, all of that is done from scratch. So, yeah, we've essentially been running that facility for the last 3 years now. And every single prototype that we've ever produced, every single battery that we made has been made within under that roof.
And what's your capacity there? How many batteries, or
So
what's
today
the way in
it's
which?
set up, yeah, today it's set up for 2,000 batteries a month. So it's essentially doing around 5 megawatt hour a month. But we are actively scaling it now to basically get up to 25 megawatt hours a month, basically to give us 1 gigawatt hour capacity by the end of this year.
Okay. Uh, what does that mean? If you look at, say, what was Log9 doing, or what would be these household names like Exide and all be doing? Not for their lead acid battery, but for the lithium ion and the EV kind of batteries. What would be their capacities?
I'd say it's today actually active output for most of us is in the single digit megawatt hour per month. I wouldn't know to be specific what peak megawatt hour they do, but just to put it in context, like for two wheelers at least, most of these batteries are 2 kilowatt hours. And yeah, if we're doing, let's say, 1,000 of them, we're doing, let's say, 2 megawatt hour. So I know for a fact that they were doing a few hundred a month. So maybe they were doing like 5 megawatt hour a year or something. We're essentially at that around monthly, but yeah, it's kind of scaling that.
That is compared to Log9. What about these? Who are the other big
I think
battery?
Excited not very vocal about this to be honest, because they actually supply like just like multiple things here and there. But
Oh, so it's hard to get a split
yeah,
of. Okay.
so I just maybe put Ola in context. Like maybe let's take Ola. So today they're doing almost like maybe like 60, 70 megawatt hour a month because they have 20,000 vehicles. Let's take and four like 3 kilowatt hour each. So that's almost 60 megawatt hour a month.
Okay. Okay. But you would be in like the top five in terms of your capacity to produce batteries in India.
I'd say there are multiple versions of companies within this, right? Like there's, let's say, like all your basic companies in the NCR region, which basically produce batteries for e-rickshaws. I think that volume is pretty high. So if I had to take just the two-wheeler, energy-focused, deep tech kind of startups, definitely, yeah. But yeah, that pool keeps getting more and more complicated as you grow it, right? Like because you have some golf battery companies also. You have like telecom battery companies. You have mobile phone battery companies. You have like pouch battery companies for like small portable batteries. So yeah, they're also all battery companies, but yeah, within the segment we operate in for sure. Yeah.
Okay. 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 Understood. Okay. Okay. And you manufacture the charger also.
Yes, we do assemble the chargers ourselves now. We essentially first when we started was were purely focused on batteries, but have realized that the actual ability to control the charger then gives us a huge influence on how we can like, scale this market. So yeah, we're setting up our own charging network. We have almost 800 points in India today, and that should be up to like a few thousand in the next 3 to 4 months itself.
These are what like these are. This is like a service business where you get paid per unit of energy consumed, or is it like an outright sale of a charger, or a franchisee run? What are these 800 points?
So today, some of them are essentially outright sales to like a company like Domino's who just operates it, but a lot of these are actually being operated on a rental model for the companies like Blinkit. So the riders are paying us a monthly like lump sum amount, and the charger is completely factored into that. So it basically amortizes over 15 months or so, and basically recovers in 15 months or so. And The idea is that today the charging network we are setting up is specifically B2B focused. So we already have a captive customer. Like, so when we set it up, let's say we'll set up 5 fast chargers in one Blinkit dark store. So now that might have, let's say, 50 riders who are now going to use it. We're already very clear that this is going to get utilized 18, 19 hours a day. And they were not hoping that this will, like, let's say, get to a certain utilization someday. Because today, from a utilization perspective, when it comes to fast charging, I think would be one of the highest. Because we have been very clear about setting up a very captive network, which then goes along with our battery powered vehicles. And yeah, then interfaces directly with the store who we work with.
Okay, okay. I'll come to the Blinkit model, your engagement with them, but let me go a little bit deeper into the charger. I I believe the chargers also went through a format war. Like, what is the best format of charger and all? Just give me like a history of chargers and what does Tesla use as a charger? What are the standards in this different countries are using? Are they compatible with each other? Because fuel is like, you can go to a BPCL or an HPCL or an Indian Oil and you will get roughly the same thing. There is no compatibility question mark there. What is it like with chargers? Just take me through that journey.
Absolutely. Yeah. So there has been a charger war. I'd say on the bigger vehicle side. Like, if I take back maybe 10 years, there were almost four standards. So there was the CCS standard, which is like the popular European American standard, CHAdeMO, which was a Japanese standard, a couple of others I'm forgetting, GBT, which is a Chinese standard, and NACS, which is the Tesla standard. And all of them, I think, are still fighting a little bit. But what has become the global standard of the last 10 years is CCS2, which now Tesla's charger is also replacing with an NACS in the US, at least. So CCS2 in India at least has become a standard for cars, for buses, and for anything which is what I call high voltage, so anything on the bigger vehicle side. But that hasn't really translated to like light mobility or anything smaller, because most of those are low voltage systems, so, and they use lesser power. So on the bigger vehicle side, there is some consolidation on the charger connector standard and the protocol. So it's CCS2 with a similar protocol, and there's some people are fighting with the Tesla converter, but that's also like you can attach it and then make it an adaptable connector also. So that's kind of solved, I'd say. But they have a different problem where now multiple companies have different apps to then like use those chargers. So that is its own problem. But that first stage of the problem where the connector itself is not solved for is actually still the case in two, three wheelers. Because if I take Ather, Ola, and TVS, and even Bajaj, and even Hero, they all use different connectors. Only Ather and Hero uses the same standard charging system, but pretty much everything else uses their own standard, and they're really not agreed amongst each other as to what the future has to be. So that is a big open point to the light mobility segment. But yeah, I'd say in the four wheeler segment, that's somewhat clarified today. So that's why you'll see a lot of companies scaling a four wheeler charging network. So you'll see, yeah, ChargeZone, Tata, Geo, Static, all these companies doing well. But in the two wheeler, three wheeler charging network, is only a couple of startups doing it. And all of them are doing their own thing today. So Ather, Hero have combined to do their own thing. Ola is doing their own thing. We are kind of doing our own thing. And yeah, it's a little bit broken. But I see that consolidating hopefully in the next 2 years. It's just mainly a question of OEMs talking to each other, though. So it's not going to be easy.
The connector war is like, say, Apple's Lightning connector versus USB-C, something like that. Like the
Yeah, but it's so much worse because there's like seven people in this, and like none of them are actually as strong as Apple. So it's more like there's seven Samsungs, and all of them are fighting with seven different USB versions.
okay.
And so, yeah, it's going to be a much harder problem to solve. Like Apple, it's just like, okay, the EU mandated it, so they pushed them, and so now Apple had to change. So if they had not mandated, they would never have changed. And then they really realized that, okay, our laptops also charging the same connector, our phone. It just makes sense for us also to change the connector, because now all our devices can basically use USB-C. That really doesn't play out in the vehicle world as such, because it's not like even if I have a car and bike, they'll use the same connector. So most likely I'll have two standards there. Now all the OEMs have their own opinions, so now they'll have their own war there. And yeah, then somebody has to set up charging also. So that problem hasn't even started solving for you. So yeah, I'd see that being a blocker, but honestly, I don't see that. I say that's an obstacle, but not a complete blocker, because sales are still happening. People are still buying vehicles. It's just that the interoperability is not there, and it just hurts the speed and the overall scale, but not, yeah, it's not a blocker by any means.
Yeah, it's like the early days of mobile phone. I remember buying my first phone, which was a Sony device, and Sony had its own charger. A Nokia charger wouldn't work for a Sony charger, and all of these
Yeah,
issues
no,
were there.
absolutely. It's where we are today,
Yeah,
I think, I'd say. But
yeah.
yeah, it's not even like the same, because at least those problems could be globally solved also. Like two-wheelers and three-wheelers will just be our government's problem to solve. And for them to come up with a very clear mandate, which is then going to overpower OEMs in India, is also not easy, because all of them are lobbying pretty hard for their own kind of opinions. So, yeah, I
Because
don't know.
there'll be a cost of upgrading or replacing if the
Yeah,
government was to
and then
mandate
which
one.
OEM will bear it? Like, why should one OEM
Yeah,
bear it over another? Yeah, there's so many issues there, right? Like, Ather and Hero have tried very hard to like convince a lot of the other OEMs to kind of switch to their standard, and they've actually, in fact, nationalized that also. So it is actually a standard, but nobody's really cared much even after that happened. So yeah, it's kind of sad. But yeah, we as a company have always felt like we today use the most common connector. It's actually one privatized Chinese company, which actually four or five companies use. But tomorrow, if it changes to Aether standard, we'll more than happily change to it. Today, most of our chargers have like bolt-on connectors, so you can actually replace and swap it out if required. Because we are ready for that problem to hopefully be solved one day. Because
what's
we
the
don't
cost of
want.
the
Yeah.
connector?
Yeah, we'll bear it if it comes to that. If it, like
Or
if
what
it
is the cost?
I'd say it's like 1,400 to 1,500 rupees for the pair,
Ah,
which is not
okay,
cheap.
negligible.
Yeah,
Right,
but it's
right,
not
right.
cheap, but yeah, it's not like the
Yeah.
largest amount.
Yeah. And so, what is the CCS2? This is the charging technology in terms of how the current flows. What does it define? Like,
So it's basically like if you look at any car's connector, so it has like multiple holes in it. So why those holes exist in the certain way they do, what size each of them are, when you connect both of them, which ones talk first, then which one talks, then how does the power flow happen, what kind of authentication do you do? All of that is the CCS2. It's a combined charging system, number two, because it was just the second one. There used to be CCS1 also. That basically is the whole standard. So it's essentially a protocol and a physical connection system for the entire vehicle.
okay, and what you're using is also CCS2, the from the Chinese company which you mentioned.
No, actually. So for our cars and for our bigger packs, yes. But for our vehicles that are small and if it's a low voltage, we actually use another connector, which then mainly only goes in two wheelers. So there is no CCS2 equivalent for two wheelers and three wheelers because globally they just don't care for two wheelers, three wheelers because yeah, cars and above are their focus. And they're in fact focusing on another system called MCS, which is basically a mega charging system for like trucks and buses because obviously it's more lucrative there, I guess.
Right, and they need a lot faster speed of charging. So okay, interesting. And w- this Tesla's NACS, what was that about? Like,
So NACS is technically a, CCS3. I call it that way because Tesla, just being the kind of company they are, felt like they could just do that connector also better than whoever else was doing it. And technically, they did end up doing it better because it's much smaller. It's a like lighter connector. It transmits more power than CCS2 because CCS2 is a global like non-profit company and they're competing with Tesla now for some reason. So it's not fair. But now Tesla is pushing more people to start using NACS because Tesla has the biggest charging network in the US. Like all the other companies combined don't have a charging network as big as Tesla does. So it actually allows Tesla that kind of power to push like their connector down every OEM's throat, and like it makes all the sense for every OEM to switch because they get access to a convenient charging network, which then helps their customers. That is not happening again in two three wheelers. Like it's nobody's as big as Tesla in this segment, and yeah, it's going to be very difficult to standardize this.
okay,
I
okay,
think a lot of
okay,
people have tried.
interesting.
It's very hard.
Hmm. Okay, got it. Interesting. Okay, so now we've covered charger, we've covered battery. Do you also do solar yourself, or you work with someone else?
So we work with someone. There's no innovation there. Like we
There's
want
no
to
innovation,
set
right?
up. It's a more of a buffer, like
Hmm.
transferring system. But yeah, there's no innovation there from our side.
Okay, got it. Okay, so now let's understand the Blinkit model. You said you charge a rental, and that rental is for the rider to have access to vehicle plus power, uh, right? How is it priced? And just help me understand that whole model.
Yeah. So today we essentially are fronting this whole ecosystem, which essentially revolves around fast charging. So we'll work with multiple vehicle OEMs. So we might give like a small low speed vehicle, we might give like a big high speed vehicle, we might give it a scooter style vehicle, might give like a slightly big scooter, small scooter. So there's 4 or 5 variants from different companies. All of them essentially then become the base model for the same battery pack that we have that goes into all of them. So we essentially supply this battery pack to these companies. We essentially then go to
Do
Blinkit's dark store.
are the battery packs compatible, like, or do you have to make a different form factor for each of
So
these?
the good thing about what we did was in the beginning when we started, we actually measured a multiple scooter, measured a lot of these scooters. We measured multiple of them, their dimensions, understood what they were. So sometimes we have to make modifications again in the output connector. So we might need like another harness to like just kind of deal with that. But in terms of size and form factor, we are actually compatible with most scooters. Not all. So if I today, let's say, try to do Ather or Ola, it would be completely different. But the ones we supply to pretty much all use similar sizes and standards today. So that's been the good thing today. We can actually supply the same battery pack for multiple companies. And that's actually happening. So we produce one particular pack, we call it Zen Pack, which is a 2.2 kilowatt hour. And we supply that like more than 1,000 of them to multiple OEMs today, every month. So yeah, once this is input, the vehicle along with the battery then gets shipped, let's say to a Blinkit dark store. So 40 or 50 of them will go for 50 riders. In parallel, we are also now going to that particular dark store and working with the dark store owner to set up solar and battery and set up, let's say, 5 or 6 fast chargers there, right outside or inside or under their dark store, like in the basement or in the parking lot outside. And by the time the vehicles arrive, now you have this whole ecosystem complete. So then we give rider access. They have an app to view all this. The dark store owners has an app to view all this. The fleet operator has an app to view all this. And every month they're essentially paying us a flat rental, which again, based on the vehicle, varies anywhere around 5,000 rupees a month, basically to give access to more than 2,000 kilometers of usage while fast charging around 30 minutes a day, basically. So a rider comes up to a charging point, they essentially use that a couple of times a day, get almost 120 kilometers of range, basically using that. And then the interesting thing is they're actually charging it only when basically they're picking up deliveries or they're taking a downtime for some kind of food or some kind of idling. They're never actually going somewhere to charge. So the actual downtime is zero for us now. They're never going to a station, they're never going out of their way. This model is basically what we're pushing to dark stores and restaurants for that matter, because we see a lot of collection of these vehicles happening around these. So it becomes all the more obvious for us to then basically set up all this there. And this basically helps the end user a lot. Like, so you might have a Blinkit or BigBasket because driver retention is also much better for them. All the drivers are always coming back. They have a very clear understanding that they're not like just going off to another service and working there. They're basically all their time is basically like to the minute, right? Like there is not 1 minute of downtime here. And yeah, just overall as an ecosystem, they're getting very clear visibility on their electricity costs. So as an entire model, the overall costs of energy are actually now driving down, which invariably is actually the only thing which quick commerce can reduce. So yeah, we are actually like at that forefront of reducing their cost as a model, essentially, basically.
Okay. Um, so the the stakeholders that you described here, a dark store owner, a fleet owner, and then the rider. Um, I don't understand why a fleet owner exists in this. Aren't you, in a way, like a fleet owner? Like you are procuring and providing the vehicles to the dark store. What is the role of the fleet owner?
So in a lot of these, so you're absolutely right. Like in a lot of the places where we go, we're directly in touch with riders, but a lot of, let's say, rider associations become fleet operators. Like so, someone might have, let's say, 100 riders in their books. Management of those riders, bringing them, generating that demand, all of that is the fleet owner's job. So they might also technically have the vehicles as their assets. Like maybe they wanted to purchase, like some of these are also just purchase and then pay the rental, but most of them are managing, let's say, hundreds of riders, which then yeah, it's its own task in a way, like because yeah, it's not easy by any means. Most of them are
So
moving from
these
somewhere.
are more like staffing companies,
Somewhere,
in
yeah.
a way, like the way to understand them. They are sourcing the gig workers and making sure the dark store has whatever. If they contracted for 50 gig workers, then there are 50 people showing up every day, taking care of absenteeism, all of that.
Yeah,
Got it.
absolutely. Yeah. Getting the
Okay.
most out of the utilized on the rider side is basically their responsibility then. Yeah. So providing
Okay.
the assets that work is our job. Yeah.
And you don't want to get into this. It makes no sense for you to be managing gig workers.
I don't think this is where our expertise like really lies, and I also don't think there is really need to do it, because the way I see it is, if you, let's say, have a 1 lakh riders, right, in this country, like just as a number, there's at least 10 lakh or 20 lakh in the next few years. But if I had 1 lakh, let's say there's 1,000 people operating 100 riders each. All we should do is find those 1,000 people that can then basically use our assets and then actually make a business out of these assets. Like, that really is our focus. Like, we want to basically scale to all 20 lakh riders, and then in fact get to, let's say, 2 crore two wheelers, right? Like, how do we get to that number? For us, it doesn't make as much sense to, like, so only keep 2,000 riders and let's extract all the revenue from those riders. We actually want the riders to earn more. We want fleet operators to earn more with the assets that basically last the longest amount of time for you to basically gain that revenue out of them. So our business will always be in improving those assets. Like, our entire company is always focused on how do I make better batteries, how to make better chargers, how do I make the chargers easier to install, how do I make better BSS, how do I make this ecosystem faster, how do I make the software better, how do I provide more data, better visibility, better financing through data. That's the focus.
Okay, okay. So when you're providing these, say, 50 vehicles to a dark store, you're procuring them, or you are just facilitating it through a financing partner on whose books they lie?
It's the second. We're actually facilitating it. Today, we have nothing on our books. We are completely asset light. We actually like sell off the batteries. Then somebody else is actually managing it. The fleet operator pays revenue through us, and then we essentially it's a pass through for us, that EMI. But yeah, we essentially paid off to the NBFC, but we aren't really liable for it essentially by any means, because again, like, I feel like there's enough people to be able to do the operations out of an asset if the asset does well. And that has really been the problem here. Like, the reason a lot of people have had to basically do assets on their own books and scale that way is either the market was just too nascent, like, you nobody was ready to do it, so we had to do it. But today, that's not the case. Like, most people understand EVs, and if you can guarantee and actually prove that there's a certain amount of reliability and total cost of ownership, more people are able to like then keep their assets on their books and kind of finance it. But yeah, our role to then actually allow this to operate and then giving that service, like, to basically make sure it's actually scaling, is part of it. Today, that's our job.
The partner who's got the assets on his book, this is what, like an NBFC typically? They
Yeah, usually an NBFC.
Okay. So they buy the asset, it's on their books, and but you said you're not liable for the EMI. Typically, an NBFC wants it's like a hypothecation model, right, where the person who's using the vehicle is on the hook to pay an EMI every month. Otherwise, the vehicle is repossessed. So how did you work out a different arrangement?
So we are actually the third part. So one of them is us, but we aren't really liable for it, only because the third party who's liable for this is usually either the OEM itself who's providing the vehicle, or the fleet operator, or the dark store owner, or the third person who's essentially operating this model. Now, in almost all those cases, that's never us. We are actually trying to use the EV OEMs to basically use that, or a mobility company, or some kind of financing company, who then basically then gives us an operating lease. We aren't looking for entities who are looking for, let's say, like, somebody who's like putting ENACH on our like bank account every month. That isn't the model, because we are providing the reliability and the visibility of how this asset works. So it's, yeah, basically that's the model.
Okay, so there's like a fixed income product for the NBFC. They invest 1 lakh in an EV and they get back a certain guaranteed return through the partner that actually is using this vehicle, either the dark store owner or the fleet owner, one of these. Okay, got it. Okay, so and the cost of battery also is instantly given to you. So from your cash flow perspective, there is like your cash flows are not getting stuck anywhere. As soon as you sign up a client, you get the upfront payment for the battery, and on an ongoing basis you earn for the energy, because you have some margin. So like you said, 2000 kilometers of, so essentially you're offering mobility as a service in a way. So 2000 kilometers of mobility in a month you are promising to the dark store for one rider, and you charge, how much do you charge for that? Just as an
It
example, what
varies.
is the
So
range?
anywhere between like 2 to 2.5 rupees per kilometer based on the use case. But
Hmm.
that's also significantly coming down in the next few months now for us as we scale.
Okay, so let's say 5,000 rupees you're earning for 2,000 kilometers of mobility that you're providing. What is the economics of this? Out of this 5,000, how much is going for the EMI of that asset? How much is going for energy consumption? And there would be some cost of the charger, etc., that you are providing, like some more fixed investment that you've done upfront, which you also need to amortize. How does that work out?
So if I take like a 5,000 split, almost 50% of that is usually the vehicle and the battery asset. Another 20% is basically the charger and all the costs associated with it. So like setting it up, the electricity cost for it, all of that. And then everything else is basically service and downtime. So like the actual cost of the manpower involved in servicing this product, some of this like basically like the software services that operate, the IoT service, all of that is a little bit of it. But yeah, it's usually like a 50% split for those assets, and then the other 50 for all everything else.
Yeah, what's your margin in this?
It's today actually already touching double digits. We are actually scaling. Today we're just pretty positive on this one, which we're the one of the only companies to be. But we should be above 20 very soon now for this.
Wow. Okay. So 50% goes to the owner of asset. Another 30% is all the other costs, the one-time investment for charger and the electricity cost on an ongoing. That OPEX and all of that is there, and the remaining 20% is coming to you as your margin.
Yeah, absolutely. Yeah. So today, OPEX for us is pretty much it's really nothing because there's no people involved in the charging. It's usually one or two people are involved for service in a region, like so it kind of go and just kind of keep check on some of these assets. But yeah, that's pretty much it. It's the rental for the area and all is kind of taken care of. The assets are very affordable. In fact, we're paying less than 100 rupees per asset per rider per month, which is yeah for the real key here.
Okay, your operating expenses are that level. Okay, got it. Okay, um, isn't there a mismatch of incentives issue that you face because the rider may mistreat the vehicle because all of these parties are like they're so unconnected with each other. I am paying for 2,000 kilometers. I'm not paying for a vehicle, so I may not necessarily care about how I use the vehicle. um so doesn't that lead to misuse and like have you encountered these problems so far?
No, absolutely. I think it's a big one, right? Like this is, in my mind, like the most abusive environment to operate because you are literally using this above 100 kilometers every day and using it for a commercial purpose and using it just not for yourself, essentially, right? Like this isn't your asset, so like you'll go through
Yeah,
every
well,
bump.
you're not paying for the asset. You're paying for 2,000 kilometers. Your
Yeah,
mindset is
absolutely.
completely different. You're not uh, at all like the you're not even thinking of I'm paying for a vehicle. Like I'm paying for
That's
2,000 kilometers. So
No, so I think there's only really like two things to do here, right? Like, one is every part of this has just to be so robust that it basically handles anything. Now that is obviously a design and engineering challenge and that's why we take the vehicles we take, right? Like we work with Kinetics E-Luna, which is the one of the bigger vehicles we work with, because it's specifically designed for this application. It's like a no frills vehicle. It's literally like a giant moped and very large wheels, no plastics. All of that becomes a much
it's
better proposition for this
it's
application.
built for abuse, basically.
Yeah, pretty much. Yeah. It's just literally engineered for this application. So
Mm.
that at least helps, let's say 60-70% of these problems you might have had, let's say if I was using like a very nice Honda vehicle, right? But on the other hand, the like second part of this is that even if let's say you put a vehicle, like you're going to have issues and solving them and keeping them under a certain value has always been the focus for us. So like quick service, quick replaceability, having certain standard parts which are easily diagnosable, and if there's actual abuse which we can then actually catch, because most of this is on a completely regulated like IoT system, you see like surges in current, you see like any abuse that is happening. We do have systems where we penalize the riders. We haven't really done it for that matter, but in the future, in fact, we are getting to the point where we will have rider based financing also. So every rider, like based on how they use their vehicle, will get a rider health score or a rider vehicle score, which is taking into account pretty much everything, like how they accelerated, how they charged, when they did it, what they did, and then start financing that accordingly. So this is obviously something in the future, but for EVs specifically, this makes a very big difference because operating for the same rider in Chandigarh versus somewhere in the south versus somewhere in the northeast, all of these will give different values and all of them will have different outcomes. So for you to be able to finance them in a variable manner will be very key in the future.
How much do you think your leakage or revenue loss will be due to all of these abuses and all that? Like, will it be single digit percentage or?
Yeah, I'd say most of the segment is accounting for a 90% uptime, like nothing more than that. Like, so 10% of this is always down in somewhere or the other. So that cost is baked into this. But yeah, the objective is to get that to 95, 98% pretty quickly. I think that is a little bit of a dream, but ideally, even if you get it above 90, the economics make sense because the assets are financed over like 2, 3 years, and the rates of interest are by no means very low. I'd say they're like double digit on the higher sides sometimes. So yeah, it makes sense.
Okay. So now, Zip would be like a direct competitor for you, right? They also provide mobility as a service
Right,
to, like, say,
absolutely. Yeah.
last
So, but
mile logistics.
Zip is also just a fleet operator, right? Like, so Zip today uses Sun Mobility.
Mm.
Now, they have essentially used swapping as their system to scale. There is no reason for them to not use fast charging. So, when we're supplying to them, like, our idea has always been that, okay, now, technically, maybe when we started, Zip was too big to supply to. So, we had to do some of this legwork to get this market started. But I want a scenario where hundreds of Zips exist and we supply to all of them. That is really the focus here. Now, to get to that, there is a go to market where we need to prove out, we need to get the stakeholders to see that, okay, a regulated, proven out system like swapping over the last 10 years is now basically being disrupted by something. Now, how do we do that? We can't just today go up to Zip and just take it. So we'll have to do a pilot. We show over 100,000 vehicles. We show this scale happen. And then I personally feel today the focus that if I look 5 years from today, more than 50% of the segment should be fast charging, and all of that should be us. There will be some players across the whole 40% who do swapping and slow charging and whatnot. But even within this 50% we supply to, there'll be multiple fleets that are running today. So we don't really consider Zip as a competitor. Like, in a way, rider deployment for us, they are basically fighting for riders, but we technically are competing with Sun Mobility to supply to Zip today. And that really is the focus here.
Interesting, interesting. So you don't care about competing with a Zip on, say you're charging 2.5 rupees per kilometer and Zip is charging 2 rupees per kilometer. You don't care about that because you're not in this to provide mobility as a service. That's not the end game. This
No, it's
is
a
just
second
a.
for us, to be honest. Yeah, like there is definitely a scenario where we want to be energy as a service, right? But
Mm,
how do you do that? Like, the mobility is a big part of this. So somebody has
mm.
to solve for it. We're working with fleets, but I also feel like this fleets and like when you work with OEMs have a certain speed and a certain process to it. But we want to be doing 1,000 vehicles a month, so we need to scale ourselves also, and that's clear. That's
Very interesting. So do you see energy as a service revenue coming? Yeah. So, like, mobility as a service has a clear metric of rupees per kilometer, in which the pricing happens. Once you go beyond this stage, right now you're doing mobility as a service as a way to demonstrate that this works, build a case study, attract other mobility as a service players to come and adopt your technology. Couple of years down the line, when that has happened, what do you think is the pricing metric going to be? Is it going to be rupees per unit, or is it going to be just price of setting up like a complete battery energy system? Or how do you think you're going to be pricing it?
So I'd say there'll be the ideal future for us. The way I see it is somebody buys a vehicle for 25, 40,000 rupees, and everything else is taken care of. Like, you buy a vehicle basically for a very small amount of money, and then you pay for the entire ecosystem over time. That
So
we believe
the vehicle cost is low because there's no battery in it. You're not buying a
exactly.
battery. You
Yep.
okay?
Yep. So the
The
battery
battery,
plus
instead
the
of
solar.
buying outright, you're buying it as a service.
Exactly. Yeah. That is the most ideal scenario here. Now, I can't expect that to happen overnight. Like today, there is no way I can ever tell everybody stop selling vehicles with batteries and now everybody start buying this way. There is a process there, and I think we are clearly on that path now. So now we've got riders convinced that fast charging is right. We're starting to get OEMs convinced that it's right. We're starting to get mobility as a service operators convinced this is right. When all three combine, this can start happening, and this is technically already starting right now, like as we speak. But today riders are so used to the concept of rental because it's such a dynamic market, right? Like, this, the vehicles change every sec. Like, I've been in Bangalore 6 years now, and every year, every, like, I've seen the hubs have different color vehicles every couple of years, right? Like, there'll be some variant of green, then they'll become blue, then there'll be some other color. and it'll keep happening. I think till this market stabilizes, that definitely is the case. And yeah, I think we're in the fag end of that stability, because over the last 2 years, consolidation is very heavy. You won't see that many companies raising that many rounds, even seed for that matter, in this segment, because it is starting to like narrow in on certain companies. And yeah, we believe that we can take that whole chunk of fast charging light mobility in that segment.
What's the unit that the pricing is going to hinge around?
I think it needs to come down to 1.5 rupees a kilometer. Like there is a 1 rupee per kilometer operating number here, but with all of the capex, everything combined, it needs to be around 1.5 rupees per kilometer. Like when I see the full like bandwidth of this entire model, it has to be competitive to ICE, like within 5% of the cost of ICE. And then it has to be, let's say, like be 1.5 with all the capex of charges, all your rentals, all your services combined.
So you're saying your pricing unit will be kilometers.
It for vehicles it usually is. Like there is obviously the other side to this for the energy cost itself, and that for that we're targeting 4.5 to 5 rupees a unit long term. But the impact of that, especially in the segment we're operating today in quick commerce, is usually down to per kilometer. How much am I paying? Because the quick commerce companies are calculating their delivery cost based on that.
Right,
Like,
right. That's the metric they care about.
yeah,
Hmm.
so that determines that value.
Okay, okay, okay. Okay, so like just to draw an analogy, you have fuel at whatever, say 100 rupees a liter, but typically a quick commerce company, even if it's using ICE, would not be calculating how many liters it's consuming, because there would be somebody in the middle
Yeah,
who would
yeah.
be charging them a per kilometer rate.
4 rupees a kilometer, that number, yeah.
Right, because and they provide a vehicle and a rider and the fuel, all of that combined, and then they charge a per kilometer rate, which is how the logistics industry typically works. They convert per liter rate into a per kilometer rate for their clients. Um, so in your case, you probably will not actually be the person who's converting to a per kilometer rate. You would be serving the companies which are doing this conversion to a per kilometer rate, but you're saying you would also price it at a per kilometer for your mobility as a service clients.
Not necessarily. The understanding for it is very clear, right? Like if a rider is, let's say, paying this much for the asset, and if we're getting the electricity cost to this value, the per kilometer cost will only be a combination of both. So in my mind, a per kilometer cost is a combination of all the capex involved plus all the opex involved. Now, except for the vehicle capex, everything else is in our control, like the battery cost, the charger cost, the electricity cost, the conversion between those units. Everything, only the vehicle is a let's say like a variable here, which will be 25 to 40,000 rupees, or 20, like maybe 50,000 rupees without a battery. And that basically impacts like point 0.2, point 0.3 rupees per kilometer. But everything else is actually in our control. So when I am saying this as an idealistic model, if you want to scale to 10 cities in India, all of them should then get to that same value for all those fleet operators. Because if it doesn't, then none of them should trust me. None of them need to be using, they're only using this solution because they know that they can hit that value, which will then allow them the reliability of hitting a certain value in their businesses of running fleets. That really
Right.
is the key
Okay.
here.
Okay. Okay. Interesting. Yeah. So if you were pricing it at a per unit for the fleet operator, the mobility as a service provider, they would still have business risk of that. What if the number of units that I'm consuming is going up, but my kilometers is staying constant? So you are eliminating that risk for them, and you're saying you are charging your customers per kilometer. I will also charge you per kilometer, so there is zero risk for
And
the
it's the
energy
easiest way
cost.
to do it, because like most people like, like not everybody is like some engineer is kilowatt hours and all this, like not everybody likes getting into
Right.
kilometers, but like it's the actual
Right. Yeah.
metric that
Just there's
drives
a
it.
scalable way of doing it. Okay. Very interesting. Um, you're able to charge the kilometer. You're able to track the kilometers just because of your battery being there in the vehicle.
Yeah, down to the meter for that matter, because today it has IoT, it has GPS, it has an entire count for how much energy it's consuming. So yeah, we have multiple ways to calculate that based on distance and based on energy, and then we combine both and then actually give a very accurate reading for it.
Okay. So my last question to you, Shitanshu, what's your advice for entrepreneurs? And you've been you're doing something like deep tech, and deep tech is like a really hard sector to work in. Everything from raising funds to finding PMF, all of these are extremely hard obstacles to overcome. So what's your advice for other people who aspire to be deep tech founders?
Right, yeah, it's a big one, right? Like because all of the it's the confluence of the hardest things in the world, right? Because you're genuinely doing something which is unpredictable. You don't know if the research will play out. Forget the market fit. You don't even know if it'll clear research, then go to product, and then go in that fit. So I think the one big thing I've seen for that's working for Rahul and me is that we're always super curious and we're always like doing something. Like so, there's never really like a moment that we're not really like thinking about batteries or thinking about this scale, or really just this is this is not a trend for us, right? Like this has been everything for us. Like we've been like this has been piling up for the last like decade or so. So I think a lot of people think that deep tech happens overnight or it takes like a year or two, but yeah, just to get to that point takes so much time, so much resilience. So the only big thing I have for people is that just stick with it. It takes years and it takes hundreds of people, hundreds of hours, hundreds of like just everything to really get this right, right? Like, and even when that happens, it's a miracle because there's so many things that you have to get right for this to work. So I feel like there should just be more and more people doing this. A lot of risk being put online. Yeah, just go at it. Like I feel like nothing this will be easy ever. I don't think it's even today for us. Is like no form of success has actually come. Like this is like the stage one of the zeroth stage, right? For us, like the stage we're at right now. So I don't see us like working any lesser or working any slower for the next like few years to come. But that is just what this takes. Like I don't think we're ever thinking that, oh, I just like we should build this for a couple of years and just get out of this. It'll not work out. It'll not work out for us. We're destined to fail if that is our attitude. Like we I've been seeing this for years. I've been trying to find someone like Rahul for the last decade, and actually meeting him like changed my whole perspective of this and allowed me to have a bond which has allowed this to scale, right? So yeah, be curious, keep searching for somebody, keep searching with people who you like interacting with. And yeah, if you have that slightest thing inside you that you want to just go out and do this, don't hold yourself back. Like, there will be 100 things stopping you from doing this, but the best time is just now. Yeah, if you feel like that you're there and you want to just put your next 2 3 years of your life into actually making something happen, yeah, just go at it. Don't listen to anybody after that.
So,
Yes, guys.
are there de-risking strategies? For example, Log9 made a bet on LTO, and that bet kind of like worked out very badly for them. You could have also made a wrong bet. Is there some de-risking approach you took which kind of saved you from wrong bets, or is it the nature of deep tech startups that some of them will fail, and it's okay? I mean, that's how it is.
I don't think there is something specific we did to de-risk what like they did, right? But one thing is that our understanding of this sector and this tech is so deep that even before they had executed what they were doing, we kind of knew what that entails. Like the understanding of what that chemistry allows, the understanding of what that tech actually allows, how that will play out in the market, how it will affect your finances, how will your business evolve, what kind of money you'll have to raise based on that. These are certain questions we asked ourselves to basically understand that better, and that really just comes from our just
So
focus on this.
it's not just tech understanding. It's also
Yeah, yeah,
like
no,
the
100%.
commercial understanding. Well, you could see through the finance problem here. Essentially, it was a financing problem, which
Yeah,
you.
this is not a research project for us, right? Like this is this has to last 100 years. This has to set up as like a foundation for years to come. So thinking 1 2 5 and then 10 years and then building it while you're doing it is very important. I remember one of my previous like bosses had told me this, like running a startup is like flying a plane while you're building it. And there is really no better way to say this. Like you don't know when it'll crash, you don't know what's going to happen, and yeah, we just keep building it anyway and just keep trying to.
How did you develop the finance instinct? Like you have a finance instinct because of which you saw that the LTO battery is not the way to go. How did you develop that? Like that commercial understanding of technology. That you're not a pure technologist, but you are also you're like an applied technologist. You can see within the marketplace what will work.
I think again, this just comes from like the depth of just looking through other companies, what has worked for others. Like the simple answer to this is that there's nothing much other than this we do. Like we just focus on this and that's all we do, right? Like I don't know anything about like 100 other things that happen in the world. I might not even know what like the news that has happening today, to be honest. And that really is what it takes. Like that's what I'm trying to get to. Like your complete
Singular
madness
obsession.
to everything else. Yeah, and just uh, today, we know like how many vehicles who sold like in a monthly basis, who's number 1 to 8. Normal people don't know all this, like, and they're not supposed to know all this either. So, but within your sector, if you're going after, you better know this, and like you better know every single's like head, like every what they're connected to. And I think the big picture, at least for a founder and like for someone in my position, is to be able to like literally visualize like a company as like a picture in a way, like to be able to like see all those nets like forming, all those connections forming, which needs more focus when. Yeah, it really just comes down to that. And again, we're all still learning this, but the again absolute just focus on making this happen, and making only this happen and nothing else happen, is why we feel like there is a slight chance of success then. And that's all you can like try for, is just slight, like the probability might be a little bit higher, but it's never going to be one. Yeah.
I'm going to slip in one more question because of your obsession. So, if I'm looking at personal use EV two wheeler, which one would you recommend? And if I'm looking at commercial use two wheeler EV, which one would you recommend?
Interesting. So, personal, I think I would say Etherista. Like Rahul's father uses it. He's had it for a while. Yeah, and Ather as a company, I just I like for multiple reasons. Commercial, I definitely say eLuna with Emo's battery pack. I think you should definitely take that one. It's a pretty strong choice. But yeah, for personal, I would recommend it because I don't think people want to use eLuna as a personal
And
vehicle.
one more question. So, should I charge my phone on fast charger or slow charger?
Ooh, it really actually depends on what phone. So I always use a fast charger and I regret it a little bit. My battery has degraded a lot. Phones are tricky. Like different phones have different abilities. Like I know Oppo is better charging than others. Vivo is a little bit. So yeah, I think it depends. If you use your phone like for 1 year every year, then you please fast charge it. No one cares. But if you're using it for 4 years, if you like want to extract everything out of your phone, then yeah, you should slow charge. I think phones have got to the point where most people are changing every 2 years. So after 1 year, everybody's anyway carrying around an extra battery or a charger all the time. So yeah, whether we like it or not, we're actually fast charging most of the time now. And that impact of slow charging will show up over months, which then you won't really see as you use it. So yeah.
Okay. And if I'm buying a power bank, there are different technologies of power banks, right? Which is the best technology to buy?
Sorry, just maybe to elaborate, like what your examples
Like
are.
a
Like,
power bank, like for the phone.
also whether they connect or they go on the back that way.
No, no, no. Like there's lipo also, and there's lithium ion
Oh,
also. And like,
so actually, that's basically the chemistries for cells. Like LiPo is pretty good. LiPo is like LFP variant. So yeah, that works pretty well. Yeah, lithium polymer.
mm, okay, okay,
They're the
awesome.
most newer ones here.
Yeah. Thank you so much for your time, Shitanshu. It was a good,
Oh, please, actually,
high high
thanks so much.
information kind of a conversation, but I truly enjoyed it.
Oh, please, thank you so much. Yeah, it's great.